the documentation in it. Before HOL, nothing but hands-on, and after the HOL, kind of while doing the HOLs. And this is the content of whatever we have it. So let me just go here and see here. We have the hands-on labs, all these things. This is all MD files, nothing but a GitHub repo files, where you can go to your GitHub account and then see it from there if you want to see it. Okay, and the more important thing is the before HOL. We'll see them one by one now. So today we're going to do an end-to-end workshop, which is kind of ending starting with data ingestion to kind of having the machine learning modeling, and how do you materialize the material machine learning modeling, and then we go with Databricks, kind of how what having a data engineer versus data scientist versus a deployment engineer. So we'll see define those paths here and see how does it work. Okay, so this is general practice what we do it, and I just want to bring up everything into one plate and then show it up, and how does Databricks work in this ecosystem, how does machine learning work in this ecosystem, how does modeling work in this ecosystem. So we'll see those concepts one by one today. Okay, so in this process, let me just go forward and I'll kind of touch base the requirement first of all. Okay, so you can just go down. This is the HOL part, and this is what we're going to do it today. Like kind of there are around 7 exercises, but we'll see what all we can do it today. Okay, and the overview is more about a travel company where they are basically booking the business travels for their clients. So these customers are corporate, the CXO level, so they want to make sure that if they want to predict and find out if any flight has a pattern of delaying by 15 minutes or not, because the time is most important for them, and they want to kind of be competitive in this world of kind of understanding. So they wanted to bring up this point of saying that like what all what all possible options you can reduce this reduce by finding out which flight is getting delayed by 15 minutes or not, or kind of maybe beyond that. So for this, there are a lot of patterns, right? Like we have to go with the past historical data saying that which departure location of the flight is, and which flight name is it, and where is it getting delayed mostly. Is it getting every time delayed, or is it only getting from one location delayed? Or it can be even based upon weather conditions. Maybe the weather conditions are very weird in that spaces, in the kind of airports or nearby airports. So it might be delayed on that space also, right? So we're going to see those patterns today and try to work on it. Okay. So in this process, as it takes a lot of time to create a cluster and create this blob storage, I have created all these things. I'll tell you that one by one. We'll go and see that. Okay. So this is the architecture we're going to build today. Like kind of we'll have some existing data of flight delay data and historical data, weather data, and combination of flight and weather and airports. So we'll see those things. There are around 3 files in this, and we load it into your blob storage. I have already done that, and we load it into our Databricks account, and then we apply our transformations and everything here. And then we apply your machine learning services on top of it, and make sure that we use some containerization of this, like kind of creating an API scores. So we'll read that, and we'll try to visualize it in the Power BI reporting. This is the whole end-to-end workshop we're going to do today. So before going forward, any questions, anyone in this space, like kind of anyone is new to anything here, let me know. I know people are new to machine learning services, but anyone has already worked on machine learning services before?
Yeah, Sachin, few queries. We are
Yeah.
using Databricks cluster, right? But yes.
I didn't get you. Database cluster, yes?
We are using Databricks cluster, and
Yes.
what is the configuration of that?
Yeah. Okay, I'll show you that. We'll kind of work on all those things today. We'll see the till now we see community edition, right? Now from today we'll see the real edition there. Kind of we will go with the not real creation of Databricks account and see how does it work. It'll be kind of 2-node cluster. I have to create up 2-node cluster with around kind of scalable up to.
On what basis you have decided cluster size for Sachin?
Okay. Okay. See, basically the cluster mapping is more about the volume of data and more about what all you are going to do it. Like kind of, let's say if it is more than kind of you are getting data continuously from streaming data something, then it's better to have a auto scaling mode enabled for it. I'll show you that. I'll show you that maybe. I guess I'll answer your question once I go there. Okay, that'll be
Yeah.
better, I guess, because
Well,
instead
actually,
of
Azure ML is the degraded version for machine learning, right?
no,
Because
no, no.
in the last project they mentioned Microsoft mentioned it is
That
going
is
to.
the old version. That is the old last year version. What we are talking about. But that is the new version which came out. I'll tell you why we went there also. Why
Okay.
they degraded it also. I'll tell you. There's a reason for it, and we'll touch base that also.
Yeah.
Yeah, I'll just write down this point, and I'll make sure that we'll touch base this again. Also, you can remind me at that point.
Yeah.
Yeah.
Fine. Yeah.
Okay, Sananda. So any questions? Any other ones? Okay. So I would say let's not do it in parallel because it'll take a lot of time and you'll have to go through a lot of issues. So we have recorded video with you, and we have only 3 hours time with us. So I would recommend everyone let's kind of concentrate only on what we are discussing till the end of the session, and we have enough time to do this. And even it can do it in community edition also. The only thing what we're going to do is we're going to apply your kind of ADF last level, but we'll see that like how can we automate it. Okay. So, but I would say let's kind of concentrate on what we're going to discuss today because it's more about understanding things because most of them are very new to Azure machine learning and everything. So let's kind of concentrate on that space. Okay.
So it's
So
give the output of the ML is JSON,
no,
Shashank, or any other format.
yeah, it is the scoring file is JSON file. The kind of the output is mapped as JSON there, but we load it into your delta tables, not sorry, the normal tables into the data bricks, and from there we expose it to your Power BI reporting.
Okay. Okay. Fine. Yeah.
Yeah, it's by default JSON because that's a REST API, right? So it is a scoring API. So there it'll generate a JSON file, but from there
But
we're trying to transform it.
machine learning will be processed lots of data. So our web service only supports 10 MB. I get that, but if you get 1 GB, 2 GB kind of data, then it's not supporting, right? Our web service.
No, no, it's more about going with container services. Like what container service you're going with. If it is just a Docker container, it may not work for you. If you are working on some real-time application, like let's say the Amazon recommendation, right? The
Okay.
main problem is we have to go with the Kubernetes there, not with Docker containers. Kubernetes can scale up and scale down automatically based upon the volume of load. You can define the bandwidth there.
Okay.
So if you by default we go with the Docker container. If you're a developer or let's say any testing environment, UAT environment, you go with Docker containers. But when you go with real-time application, then we go with Kubernetes. Never recommended to go with the Dockers.
Okay. In our example, what if we are taking that Shashank?
Now we are going with Dockers only. Dockers, we are taking mapping it Docker with the containerization there. Containerization we are defining it.
Okay.
Yeah.
Okay.
It's the same thing, kind of. This nothing different, but thing is that we just kind of define it as Kubernetes or kind of AKS or ACS. That's it. The only difference.
Okay.
Yeah. So let's go to this content here. This is what we're going to build it. So we'll go one by one. There are multiple steps inside this. Like kind of first of all, loading all this data into Databricks because we are going to do the first thing is right. The requirement is to do an prediction on the top of this, right? So you get the data continuously. But when you're getting the data continuously, the more important thing is, first of all, you train your data, right? But train your data on algorithm with the existing data sets, and then build a model, and that model will be exposed to your real-time processing, right? So that we'll see that here. First thing. Second thing is then once the before kind of preparing a model, we have to prepare your data, right? We have to do a feature engineering, right? So let me just go forward and try to go with Paint here, or let's say Excel sheet is the best one, I guess. 1 second. Okay. So steps involved. Okay. So let's go one by one. The first step is more about. Okay. The first step is more about data preparation, right? because before passing the data into my model, first of all, I have to define my data set. Like example yesterday given, right? A date can be of n numbers. Stavani, can you be on mute, please? So data preparation. So this involves multiple things. Like let's say I can give an example of first thing is cleansing the data, cleaning the data. Like if you have any missing columns, or let's say if you have any kind of any junk characters, or let's say any predefined values. Like let's say if it is null, give it as value of m or n. So kind of and if it is null value, give it as n value. So you have to kind of change all these things, and the date patterns might be different in multiple files. So we have to make sure that all are in the same normalized format. So this is all direct cleaning process. And the other one is more about let's say kind of augmentation, data augmentation we call it as. Basically nothing but we're trying to make sure that the data is efficient enough to pass in. Like example is a date can be converted into multiple types, right? Example is let's say if we have a date here. Sorry, something happened. Yeah. If you have a date here, right? A date can be a week, right? Or it can be a day, which day of a year, or let's say a weekend, it's a weekend or not, or it's a month end or not. So I can do many dimensions of this date, right? The lot many. The same way, let's say I have a country, right? Country is let's say India, Germany, US, Canada, Australia. So this is nothing but a kind of categories, right? The category of India, any record which is fitting into India will come under this section, right? And nothing but categories. So what I can do is I can create new columns on this top of this. Like India is a new column, Germany is a column, US is a column, Canada is a column, Australia is a column. So what happens when a record comes as, let's say when a new record comes with Germany, right? So I'll say this is 0 and this is 1. This is, okay, let me do one thing. I'll just take this up here. Okay, let's assume that we created multiple instead of having this India, Germany, US, Canada, and all these things. I'm trying to have them as columns instead of rows. So whenever a new record, let's say first record comes into my system, then I'll see if this record is containing the country as India or Germany, whatever it is. So let's assume that this first record has got Germany as a kind of Germany is a country. So I'll say remaining all zeros, and this is 1. This is nothing but augmentation, kind of one-hot encoding we call it as. Let's say second record is getting US as the record. So I'll say remaining all zeros, this is 1. This is called one-hot encoding. Like kind of if you remember this matrix creation, right? This is the same thing we're doing it, transpose. So it is kind of, we are trying to make sure that we are trying to transpose this into a matrix of this kind of thing. Right? Let's say if you have 100 records, we define all those things here. So by this, the algorithm can easily understand or easily rationalize the things which should be very important, which should not be very important to consider. Okay, so this is all nothing but data augmentation we do it. So when you come through this kind of requirement, I guess when you go with the second section or third section where data scientists will do all those things, I just want to touch base this also. Okay, so in a higher note, this is what we're going to do today. And then once we have this, right, once we have this data augmentation, or let's say kind of or cleansing and missing values, all these things, then preparing your data. Let's say you want to do some transformations, kind of testing to integers, or let's say whatever it is. So we do all those things here. Okay, this is done. The second phase is modeling, which means that you create a model, train your model, basically train modeling. So what do we do in this phase? We divide our data. Let's say a data set contains of around 100 records. I divide them into 70 and 30. If you have 100 records, so I can basically divide it into train and test data. Okay, this contains, training will contain 70 records, and the testing will contain 30 records. So what happens with this? Okay, so let's say 70 records. I'll train my model, like all this algorithm. Modeling. So I'll do the third step is kind of modeling part. So I'll take this 70 records, and I'll apply my algorithm on top of it. So now algorithm will understand the patterns in it. Like let's say if you're using logistic regression or random forest, XGBoost, whatever it is. So it will understand the patterns inside your data, and then it will tell you, okay, I feel that this is a pattern which I am finding it. Like, let's say when you pass this kind of parameters, this kind of records, maybe India and the kind of weather conditions is this much, and then let's say the passengers is from this region, this location, then the tendency of this airport is having a 15 minutes of delay. So it finds this patterns, and the algorithm will automatically find it. How we will not be touching in this workshop because we are concentrating on big data, but I just want to touch base this. So this algorithm will understand that, okay, this is a pattern, I found it. Now what I'll do is, okay, I found some pattern here, and I'll apply my test data on top of it. Now test data. What I'll do is I'll apply this 30 records which are not exposed for algorithm training here. I'll apply it on top of this here for my model. This is called, it creates a model here, because on top of this it creates a model, and this model will be tested with 30 records. If this is working fine, I'm good. Let's say this model is giving me around let's say 70% accuracy. Okay, so now 70% is not a kind of good enough, right? So again I'll go back, and again I'll follow this process from 1 to 4 and hyper tuning. So I'll do this process again. Like hypertuning is nothing but, in this algorithm I have given static values. So the algorithm will have again fine tuning parameters. Let's say an example is, I mean, see, if you are using algorithm of some equation, right? So this equation can be modified a little bit and try it again. Again, modify a little bit, and let's say if it is y equal to mx plus c is a linear graph, right? If you remember in your school days or kind of in your college days, we have the linear graph, right? Y equal to mx plus c. So let's say I give the m value as 0.5, or let's say again I'll give it as 1, and I'll try to see the output, if it is closely fitting or not. If it's fitting fine, then I'm happy. The same way, I'll do multiple iterations inside that, and then I'll see a final model. Okay, this final model is a final model which I prefer to work with. Okay, so now this is the part of data scientist. Okay, this all is done by data scientist. Okay, done. Now next point is about data engineers, right? So once he gives this model, he saves this model in some location. It is our duty as a data engineer, or let's say as a DevOps engineer, we expose this data model, or let's say I would say final model, into AML service or some place. Generally, what we used to do is we used to kind of keep it in SVNs, or let's say CVS, and the repositories, code repositories, and then whenever they want to retrieve it, they want to retrieve it. But the problem is, like, let's say if I have multiple iterations, I want to find out which model is fitting better for last 3 months, last 6 months, or let's say I want to compare my number of iterations. This is not no option. So this AML service is giving me that options. So I'll deploy the model and test out in real time, like, kind of what is happening out in the system. So we'll see here AML services. I don't want to go deep into it. Later on, I'll go there. So it's more about kind of deploying the model, and second one is referring write web service. So they're a little more kind of defining containers and everything. This is all data engineer work or DevOps engineers. Okay. So about this is all again okay. Okay. But here again, seventh one is more about exposing to let's say DB, SQL DB, the output to SQL DB, or to Power BI reporting. Kind of any reporting, because anyways we have this into main tables, we can directly expose it to Power BI reporting. This is all again done by data engineers or data analysts. Okay, so if you observe this, this seems to be very complicated, but this is again independent of our work. This is going to eat our time, lot of time, because this is very important, and as well as this is also very important, because whatever data we provide to him, to the data scientist, is what he can work on. But whatever data we are passing is very important, right? Let's say we pass only 10 records, 10 columns. So there's no point in understanding because he cannot see more than that. But if you give him 100 columns and he can analyze it in a more better way. So what to pass inside this is very important for them. So we have to design that. Let's say if it's coming from 10 sources, we have to do it. So all the data ingestion, data ETL tools, and all this are ending up with a reporting layer or machine learning layer, right? So our role is very important in that space. So clear everyone till this point. Any questions? Anyone? Any questions? Okay, fine. So let's move ahead. So in this process, okay, let me just go to my before hands-on. I'll tell you what all I have done it. Okay, so one second. Okay, so you can go to this documentation. This is all again, this is all already there in your GitHub, but I'm just trying to map it through documentation because few people are not able to open the GitHub account. So I just created documentation for it. Okay, so let's go one by one. The first one is big data visualization before hands-on, like it'll take around 30 minutes. First one is creating your Databricks account. So this is already done. You don't need to create it because I have done it already and I'll share it with you. You can directly use this. Everyone can use this because the cluster will be impacting a lot. If everyone creates in parallel, it will not allow because there's a kind of anomaly detection saying that multiple people are creating at one time with the same account. So they'll stop it off immediately. So that's a risk I have seen it already because it's all kind of internal anomalies finding out. So what we are doing here is we are creating the first thing is to create Databricks account, right? Inside the portal, go to resource group, Databricks here, and so here if you can see this, I created my resource group, all those things. And I've given premium role-based access control. This is what I mentioned, right? When you go with enterprise scale, we have an accessibility to go with. First very important point is you can go with the user level security, the role level security, kind of the role-based security. The kind of we have different groups in AAD, you can map them to it. So we can do all those things here. Yeah. And other one is about the account creation. Right, the storage account I've created it, like kind of one is storage account here. Okay, the storage account I've given my subscription, blob storage, redundancy, and all those things like this. Okay, and then I created my storage account inside it, like this one here. I created my big data Databricks account as well as my this one also. Okay, and I have my keys. I'll copy this key because I require this. I'll tell you why. I created a container called Spark container. Okay, and I'll say okay. This is done. Okay, this is done till this point. Next one is now I want to create a data factory. This all I don't want to do it because you can just go forward and see that later on. This is not required. Now I want to create my cluster. Okay, the cluster I will go here and I'll create a cluster as runtime and type 3 and same as worker nodes, kind of FO whatever it is worker type. Uncheck this option because we are not going to work on huge loads here. Again, if you define that, it is going to impact your system. Like let's see here, just going with the standard one, and I'm going with version 3, and the worker type is this one. Again, now we have new one here. This is the old picture. We have a DS4F system, DSV2, and we have worker nodes as one here. I have given it as two because everyone is going to work on this, so I have given it as two here. But you can try kind of maybe you can try to kind of don't enable this, but just directly use it as two here. You can use my same subscription after decision. Okay. And one very important thing is I'm mapping this blob storage. If you observe this is a blob storage. We have it right. Okay. Remember that we have created in your Spark cluster, Spark container. So I'm giving the same thing here. Okay. This is the blob path. So where this cluster will be mapping with. Okay. Clear cluster. We're done. Okay. This is what I've done it, and I'll show you that also now. I'll go to my portal here. Okay. Dashboard. So everyone, be on mute, please. So I have see here, I have my end-to-end RG. And this is what I mentioned. Someone asked me like, what is it getting created? Like see here, this is what is getting created here. It automatically creates its own kind of instances and manage risks here. Okay. So I created my end-to-end RG. This is the resource group which I have it, and I want everyone to use this only. Don't create anything else. So I guess created a big data factory account. Okay. So I'll just open up this big data lab and launch workspace. Click on this. So this is what it looks like when you create a Databricks account inside your Azure account. It looks like this. Okay. So any questions still here? Yeah.
Yes, sir. Where is Databricks will be navigation? Like any link over there?
What is it? I didn't get you.
I'm to say this is the Databricks launch point, right? From
Right.
the Azure.
Azure portal.
Okay. And where is this located? Like, is it on the homepage itself,
Yeah. So
mainly?
basically, when you go to resource group, right, you have end-to-end RG. Inside that, I created it.
So, Shashank, this is the account today is learn Azure at codesystems.com, right?
Yes.
So
So
we
I'll
will
send you
use
that. I'll send you the credentials. I just have it. I just got it now. So I'll just create it. I'll send it out in maybe a few minutes. Anyways, you don't require it immediately. I'll send it out right away. And
no
I'll try
problem.
to I'll let ask them to extend it so till maybe 8 o'clock or sometime today, so
Ah,
that
okay.
you can have enough time to do it. And even if can't do it, you will have tomorrow's and even tomorrow's and day after tomorrow's, right? You just go there and execute this. It's again the same process as community edition only. You don't need to worry about. The only thing I'll tell you. Maybe I'll just go forward and tell you that. I don't want to kind of blow off everything now. So I guess you should be able to do it. It will take around 3 to 4 hours for everyone to do it, each one. So that's a very kind of little task too. But I just want to make sure that you understand the concepts here, so that even if you don't know it, that's okay. You'll be able to understand the concepts, how to work it. Okay. So just click on this workspace launch workspace. Click on this. It will open up with SSO login here. So this is what you're looking, right? We saw on this before itself. It looks the same way now also here. But thing is that we have extra things like kind of jobs. We can create jobs, as I mentioned, right? We can create pipelines, like how we do our ETL processing. We can do the same thing here also, like kind of our IDF factory jobs. We can pipeline, streamline this process and define it here. Second one is about clusters. I just now created a cluster here with 2 nodes. Just click on this. It looks a little different here. We'll say edit it. So see here, we have seen this yesterday also, but the only option we found is enable auto scaling here, and worker nodes and all these things are enabled here by default. Okay, so we cannot scale it up more than this. I guess there's some issue with this. They're not allocating more allocations. But see this is what I've enabled it. Okay, and in the advanced section, I went here and I have mapped my blob storage account here. I created a blob account here inside my resource group. I have a blob called blob storage account. I mapped that account to this here, the key values. Okay, by this it will basically map to that point. Okay, that's what I have done it here. Okay, so let me just go back and I'll go click on this users. Okay, so now what I have done is I even went back. If you can go back to documentation, I'll map with documentation so that you understand the concept. So I have some link here, like this link. Click on this link. It will download a zip file which contains 3 files. One is flight delay with airport codes, flight weather with airport codes, this one. Or you can anyways have that in your this portal here, hands-on lab files. Wait a minute, 1 second. I just want to touch bases. Somewhere I missed it out. Download it and kept it here. So maybe it is missing out here, but you can go there and download it. It is missing out, sorry. So you can download it directly, go click on this link. It will download the URL, kind of the zip file which contain these 3 files. The first one is kind of having around 400 MB of data. It is little huge data, so it might take a little time for everyone to download it. And the reason why I uploaded it here, so I went back to my my this account and I went to data sets. Once I enable my cluster, right, I went to this data, and default one I said add data. Okay, and I said browse it like how we have seen last time, right? I went back to this one here. This is the files we have it. We would say extract this. So this is a file we have it. We can extract this. I clicked on that particular file and say upload it. So once I say upload, it looks like this. It creates this files here like this. Okay. So yeah, I guess it is around 400 MB file. It takes around 15-20 minutes. So I thought, why to waste the session? I uploaded it right away there itself. So I did it in the morning itself. Like I uploaded this flight delays with the code. So that's the intention here. So we completed till this point where we uploaded the 3 files into the system like this. See here, I went to the Databricks account and I've clearly documented also, don't worry about it. So I went to sign in options. I went to default add data and uploaded my file which is around 400 MB, right? This is the flight delays with airport codes. And I clicked on create table with view with UI. So this is what we've done it last time, right? When you went with Databricks use case scenarios, we done this concept. So I made the first row as header so that I'll have header values here and all our strings here. Okay. So I said create tables. The same way I created for everything. So I could see 3 files getting created, 3 tables getting created. Okay. The next step is to copy. You just go back to your workspace. I guess this, you know this concept. Just go down here, drop down and say import and browse. You'll already find that in your system. This is a file. It's inside your lab files. Inside your lab files, you find already the .dbc file. Just click on that and say import it. You'll be able to import it. So you'll find this kind of big data viz 2, 0 to kind of bracket 2. Okay. Till this point, anyone is lagging behind or anyone missing out any concept, let me know. We can discuss now. I'll wait for a minute.
Yes, Shashank, the table which was created, we didn't have to, specify the schema or anything. Like it's all string, string, string. But
Yes.
is it possible that, if some of the data like date time or, varchar or something, so does it pick up on its own or it's like by default
Yeah.
string itself?
No, we have an option called info schema. If you can go back to your documentation, right? Let me just show you there if you can find it out there. It is not showing up here, but there's a new column called here info schema. Just enable the checkbox down this. If you have info schema, enable the checkbox. It'll show you that. Let me try it out. Let me, why do I don't know? Kind of, you can just see here, right? Let me just go to browse. I'll take some file here. I'll just take some random files. Okay, so just create a UI. So I define my cluster here. Preview table. So see here I have info schema. If I enable this, it automatically understands the table format and loads it off.
Oh, okay, great.
Yeah. So I'll just removing this. I don't want to do this. Remove file. Okay. So we loaded this. So we should, but I didn't do it because I want to do it through code. I just want to show you the how does the data preparation happens out in real world and how does the modeling happens out in the real world. And I just want to go with the step-by-step process. Okay. So that we understand it more better. Clear? Okay. So let's go forward and this is what we can see it. Like once you open this, this is what we see it out here. Okay. Double click on this. So now what we are doing is, see here I'm importing. So this we are trying to prepare your data for flight delays, which means that we are trying to kind of design our data preparation layer. Like this is what it is. This layer, first step. We are trying to clean your data, augment it, prepare it. Augmentation we can do it here also, but yeah, I'll try to do it here in next steps. But I just wanted to show you that we are trying to prepare your data as per the needs of data scientist, or basically kind of it can be done by data scientist or it can be done by us also. Okay. So I am preparing the data here. It is mostly done by data scientist where we will expose this data to him, like and how we upload it, right? We will have data factory pipeline. So in our code, what I mentioned is I'll have, like if you see up, So I'll import this data, right? Like kind of I'll just go here and say import it. But in real time, we can use data factory to move to ingest this data through multiple layers and do a transformations and load it into a destination DB, or it can be your storage blob. So from there, it is a duty of a data scientist to read the data from there, maybe by mounting it or whatever it is, and he'll read the data from there. Okay, so this is a whole set. Now what we are doing is a data scientist role. Okay, let's assume that we are a data scientist, and we'll do this. Okay, now attach my lab here, and I'll go here and say execute this code. So it is taking a little time to execute it. So I have imported all the required libraries here. And now I want to see what all tables we have it inside my default scheme of database. So I'll say show tables. It'll give me the see this. It'll tell me what all are there inside. Like in the default table, default database, we have table name of these three things. Is it temporary? No, it is false. Which means that there are kind of global tables. We discussed this point, right? Global tables, temporary tables. So this is what it is. And this cluster will not end up. It will be stopped off. It will be kind of stopped off. But again, when you go and say restart it, it will restart it again. Okay. So don't create a new clusters. Just kind of utilize the same cluster going forward. And see, here I'm trying to read this table with percentage SQL. You remember this, right? We executed the code with percentage SQL. What happened to this? The wrong name. Right, list with airport codes. Underscore CSV. Oops. Okay. We'll try to rename this. No option to rename it. Okay, that's fine. Then let me do one thing. I'll just try to use this itself. I'll just say it as underscore CSV. I can't create it again. It will take around 15 to 20 minutes for us to do it. So now see here, it is giving me all the information like what year it is. Like we are basically taking the flight delays with airport codes. So in which airport the flight has been delayed out. I want to find out that. So I'll just giving you year, month, the day of month. This is what I mentioned, right? We can do all these things when we have a date parameter. This is all done already. A carrier, like what is the carrier here? So if you see here, this is the departure time. It's not a right format if you observe it. It's all kind of in seconds format. It is not kind of divided by seconds or something. Departure is delayed by -3. And if you see here, it is basically telling you that this is a very important column. Like kind of this is what we want to predict it. Like we're saying that DEP delay kind of departure delay by 15 minutes. If it is 1, it is true. If it is 0, it is not delayed. Okay, so this is what you can observe it here. If you just click on down, you'll find that it is delayed by 15 minutes, 33 minutes, 323 minutes, and if you see here, it went a little earlier here, so it is 0 here. Okay, so now what we want to predict for the audience, for the end customers is we want to predict by passing all these parameters whether my flight will be delayed or not. Clear, everyone? Clear is the requirement, right? Everyone is clear about the requirement, right? No one is confused here. Okay. So then the next step is we have lot more characters like let's say origin code, origin name, altitude, latitude, longitudes, destination, airport names, and all these things here. Okay. This is the information about it. It is very huge data here. Let me go down and let's go CSV. Just remember, okay, I'll just change it out anyways. You can use it. So I want to see the count of it here. How many records we have it of this kind? It's around some lakhs of records. So it is 27 lakh records we have it. It's a pretty huge file. Okay, so now to do transformation on the top of this is very huge, right? So we'll see how do we do it. Okay, so let me just go down and I have 20 columns inside it. If you see this, there are 20 columns here. Okay, but the most important thing to remember is, as I mentioned you, we find something called as DEP del column. It displays when the flight is delayed and by 15 minutes. If it is 0, it means there is no delay in that. Okay, so I want to find out if there is any null in this. Okay, which means that again, if you have null, right, we can't predict the values. I hope everyone who are new to machine learning are understanding this concept, right? Because if you want to predict something on this variable, like saying that I want to predict it, I should have my data with full values about it, or else it will be problematic for me. So I'm just seeing out if there's any null values in this. This is all data kind of cleansing or data preparation stage. Oh, sorry, I have to give
In
always.
what scenarios will get null, Shashank? Usually
What's
it
it?
won't, right?
What's it?
So why we will get null value there?
Yeah, so basically maybe they may not have missed it out, or they might not be having the data, or whatever it can be, right? Maybe they have taken the information, but they missed out to map this, is it delayed or not. So
Okay.
it can be any case, but not exactly saying that this is the case. But yeah, the data set they provided, like kind of data engineer provided it, or the source system provided it, has got some null values. So it is a duty of data scientist to find out if he wants to predict this. He want to find out if it is really valuable to predict it or not. How can I say it? Because if you see here, there are 27,000 records which are missing. Out of 27 lakh records, 27,000 records is not kind of, it's okay to handle it, around 1%, right? 1% of this data. So it's okay to remove it off. It doesn't matter because 27 lakh records, 27,000 records is not much the deal to work with. So we can think of this, we can remove off later on, we can remove of this because we found that it is an issue here. We'll remove it later on. Okay. And then one more very important thing is CRS departure time. We see, if you observe this, we are trying to prepare your data in the right format to expose it to your model, right? So if you see here, it means that if it is given as 8:37 in the record, it means that it is 8:37 a.m. Okay. If it is, let's say, something else, it is be like this. So what I want to do, I want to divide by 100. Let's go and see, go up and see this. So see here, CRS departure time is 8:37. It is nothing but 8:37 is 8:37 a.m. 17:05 is nothing but 5 p.m. Right? 6 a.m. in the morning. So it will give you those records here. So we have to divide by 100 to get the right value there. This is one more cleansing process. First process is to remove the nulls. Second is to change the CRS time, departure time, right? So I'll just say I'll go and create a variable called data frame called flight delays. Okay, I'll just give it as here underscore CSV. So I create a data frame here. Now I want to print the schema now. So see here, all are string formatted, right? If you observe this, then notice that departure 15 and CRS is columns which are very, very important for us, are string formatted. So both these needs to be a numeric formatted. So the third thing is to go with creating a numeric formats. So we'll not do this one by one. We'll create all at one shot. That's what generally we do it in the data preparation stage. We'll not kind of go find out everything and do it at that point of time. We kind of understand everything. At the last, we create one function which will do all these things. Okay, that's the intention of doing this now. So the data bunging is more about having multiple options. So we call it as something called data bunging here. So we have what we have to do. We have to remove the missing values, generate new column called CRS departure R, which contains the value of this, but it contains in a right way, like kind of 8.37, right? Or whatever it is, 8.37 as a 8.37 AM or whatever it is. So, and pare down the columns only with the needed ones. Like we take only what is required. Now we have 20 columns in this, and all are not required, right? We can take only what is required, and we can define them as numeric. Clear, everyone, till this point? So, as I mentioned, Databricks allows you to work on multiple languages, right? Like kind of SQL, Python, PySpark, or it can be Scala. And you can even write your R scripting also. Okay, so let's go and see that. I'm saying percentage %R. That's it. You can import your R language and start working on it. I'm importing a library called Spark R, and see here I'm saying that SQL. So if someone is kind of new to R language, it's okay. We're just trying to understand how we can leverage Databricks and how we can do a machine learning, because data scientists generally work on Python and R languages, right? So it becomes very easy for them to work on it. And people who are already used to R language, they don't tend to go with Python because the usage is very easier for them in data preparation stage. Okay. So see here, I'm trying to read data set, like saying that select all these things, and see here I'm casting it as long, right? I'm casting this also as an int here, right? I'm taking only what is required inside. I'm not taking everything here. I'm taking only required ones. So I'll just say it as here underscore CSV. And now see first time what the first thing we have to do it once we created the only required ones here. So only columns required and casting that to have a long and int the new data frames, right? Second thing what I want to do is I want to make sure that I have to omit the not missing values, basically missing values. So I'll say na.omit from this data set. So whatever missing record we have, it will remove it off. The same way, now we will, next one is rounding off, right? So we have this departure time. So I want to divide by 100 so that I'll get it as 8.37 or whatever it is. I'm doing that here. And the last step is to kind of trim out only columns. We generally use it for predictive modeling. Like this is what we're doing it. So we are saying that only take these columns in our code. This is called as clean data set. And now I'm creating a view on top of it called as flight delays view so that I can reuse this easily. This is a data frame inside the R, right? So it's better to work on a temporary view for this creation. Okay, I'll say execute this. So it is done. Any question till this point, let me know. I'm just keeping this for a minute so that you can understand the concept here. You can just go through this one by one.
Yeah, Shashank, you have till now we have reading the data to data frame. That's it, now, right? We
That's
didn't.
it. That's it. We didn't do any modeling yet because we're preparing the data first of all.
Okay.
If you remember that we have seen this slide, right, where we have said that data preparation is more about cleaning and augmenting and all those things. So we are doing this phase now. Okay. So now let's go down and see this output. So it is giving me the right records. Now see here, it is, I'm rounding it off, so it is giving me some value here. Okay. So let's go down and get the count of it. Okay, so you can see this here, it has 26 lakh records now, 26, almost 27 lakh records, because we removed off 27,000 records. So we are able to see this missing values. Now the data set is pure and kind of right in place, right? So as we are able to see that this is a clean data now, it's good to make it as a global table, right? So as I mentioned before, there are two tables, right? One is a temporary table and global tables. So let me just create a data frame out of this cleaned one. As I mentioned, you see this global tables and local tables. Global tables can be accessed across the class, all clusters. Let's say we have three clusters here, low zone. Generally, what happens is the database is a kind of a generalized environment, right? Like any data analyst can work on it, or data scientist on it, or it can be a data engineer can work on it. So they'll have different clusters. Data scientist may be working on GPU-based systems. He's working on some deep learning models or machine learning models. So he has to invest a lot of clusters in that space. Or it can be real-time streaming data, and you want to have, or it can be huge batch data, maybe around 1 TB of data each coming day each day. So it is data engineer has to have a larger cluster storage. So it is based upon the requirement. You can define it, and kind of data analyst or let's say business analyst is not required to have a huge RAM or kind of huge worker nodes, whatever it is. So what we can do is we can create a new cluster for only for them accordingly. So, but when you say global tables, it is accessible across all the clusters. Whoever wants to read this data, they can read it and use it. Local table is only for within one cluster, and if you on it or off it, it will be lost. So, how do you create global tables? We'll say it as dot save as table. How do you create a local table? This is what we're trying already seeing it. It is called create or replace or register temp table. Okay. So we have done this with a temp table, right? Like this, create or replace. If you go up, you'll see that here. We said it here somewhere. See here, create or replace temp view. We created it. We were able to create that record there. And now what I want to do is, I want to create a main table as flight delays underscore clean. So I'm creating a table. This is a clean data set. Dot write overwrite save as table as this one. Okay. So I'll say execute. Now I'm creating a main table now. In the same way, now we have done it for flight delays, right? Now we have done it for all those things are done for flight delays. If you go up, this is a table name. This is a file name. Flight delays with airport codes. So there are 3 files. You remember that, right? So the second file is more about go down, preparing your weather data. Okay. So there's another table called, right? I mentioned you. This is the other table we have it. Other file, sorry. Flight weather with airport code. So we have seen flight delays with the airport code. Now we are seeing flight weather with airport codes. Just define this. Let's see this also. If I'm going a little faster, stop me because that's very important to let me know.
Yeah, Shashank,
Yes.
you mentioned as a global table, right? I can use even for other clusters as well, means
Yes.
not existing workspace. If I create another workspace which is not present in that region.
Oh, no, no, no. It is basically under the same workspace. Same workspace, you can have multiple clusters.
Well, Shashank, this save as table usually creates a new table. So
Yes.
is it like we are saving it into a database or Hive DB
No, no.
or
It is
something?
basically mapping your DBFS account. How we have metadata, right? It will basically map it to a blob storage. But the thing is, it is mapped with your DBFS account.
Okay.
Okay. So next thing is about this file. So in this file again we are finding the same thing here. The sky condition is nothing but the codes, what they have it, internal codes. Visibility is this is what they have it, weather type, and there are a lot many features inside this. We don't need all these things. We need only few things which are very, very important inside this. Let's go and see them. So yeah, we might have to use it later on. So as I mentioned, right, when you go here, right, when you go here, this level, maybe this model is giving you 50% only. And again, you want to go back and reiterate and take only required columns here. Instead of taking only 10 columns, we'll take 20 columns here. So we'll try to reiterate this process and again try it out. So this is a multiple iteration process. It is not one time process. It will take around maybe 5 to 6 times or 10 times, 15 times. I've seen people doing out for 50 to 6 times because the hyper tuning is very important there and the algorithm selection is very important. The data passing is very important. So they have to go to multiple levels of iterations. So it is not so easy job for them to work with. Okay. So now I'll say here underscore CSV. I'll just get the count of it here. So it is around 4 lakh records. We have it. Okay. So, and we have 29 columns. But for this model, we are focusing on predicting delays. So what are the required parameters we have it? We have wind speed as a required one, sea level pressure, and hourly prescriptions. Sorry, it is precipitations. So we want to touch base only these 3 columns from this data set. We don't want to use all those things because this is a very important features to work with. Okay. So let's go and see what are the distinct values we have it here. Underscore CSV. So we have distinct columns here, but let me click on this again. So see this, there's a 0 column here, right? So I'll just go down and we can see here there's a null and M also. These two are not expected because these are kind of numerical characters. So, but we have some kind of null values which is not mentioned. Some are mentioned as not known. That is M here. Okay. So just go down. So you see here, the column header will sort in ascending and descending order and observe that they're all numbers with some having as null values a string column and M as missing. Okay. So we need to remove this missing values, nothing but whatever missing values we have it, we have to remove them and convert it into a better format. So we have to remove this from the system. Maybe we can try to convert it in a better way, saying that if it is m equal to, then you then make it as 0.05 something. Okay, so we'll have some variable so that we don't miss the data. Okay, so in the same way, null also will be replaced with that. So this is one sort of data preparation for my system. First, data preparation, right? Second one is sea level pressure again. Let's go and see this also. So if you go down, let me try it again here. So here also we have m, right? So we have to even control this also. This is a very important feature. So we'll see that as well. Okay, so we replace this m with some numeric value. The same way, let me try with the hourly prescription also. This is again another record, another column inside my weather data. Let me confirm it. So I have T and null. Okay, so let's go and see what is it again. So this is a trace of amount rain. So it is replaced with T. So we have to replace it with some numeric value again. So there are three changes we have to do it in my weather data. One is the hourly precipitation, sea level pressure. Another one is, last one is wind speed. So this three has to be replaced with the right values there, because it has got some missing values inside it. Okay, so let's go and clean up our weather data. We have to modify this, replace missing value with the null values with 0.0 and m as 0.005. The same way, 0 this one and t as 0.005, and replace with 29.92 as an average pressure. We can't have a low level pressure here, so we are mapping with average pressure here. So and convert all these things to numeric column, because these are all string formatted. So I want to convert this into numeric formats. This is the fourth step. Okay, and the fifth step is round the time column to nearest hour and add a new column called hour. This is again fifth transformations I want to do it. Eliminated unneeded columns from the data set. This is the sixth point. So I want to do 6 levels of transformations on top of this weather data. Clear, everyone? Any questions here? Yeah, I just got a few questions. I'm seeing it one by one. In this case, do we check if time is less than 100 as well? Less than 100? No. I guess not seeing it, because it's basically shown as 0.037 something. So it will be early hours. 0.37 is nothing but early morning 12, right? If we divide by 100. Okay. So then on top of this, I'm creating my data frame. Like if you see here, right? Spark.sql, airport and month as int casting here. I'm casting it. So I'm trying to make sure that all the columns are in typecasted here, right format. And let me just say underscore CSV here, because I gave the say wrong naming convention. And let's see this now. Now let's see this here. It seems better now. I have taken only a few required columns into this. Now I wanted to name the new function called round down. So first of all, let me just go and see that. See the types here, all are right types only. So now I'll define my steps. You see here, I'm trying to define my steps each individually, like kind of saying that whether dot with column, I'm just creating a new column called hour, which is nothing but a time by 100 and floor of it, getting the nearest value. Okay, so I have done this. The next step is to replace missing values of wind speed with the zeros, right? And then replace m with some random value, and replace again m for sea level pressure with 29.92, and replace the t value for hourly precipitation with some value. This is the value. Okay, so I've defined this, and I'm taking only required columns from this. So I'm say executing this. Okay, now let's go and see our data here. So it's better now. We have right values with us. So I want to integrate this content with my join conditions. Now let me go and show you the changes also with the type. So now all are in right types here: airport code string, month, int, hour, and all those things. Okay. So now I wanted to save it into a new global table called flight weather clean. This is a new table, right? And before that, there is flight delay clean. Now it is flight weather clean here. Say yes. Let's do it. Let me get a count of it now. So it is all fine now. 4 lakh records, we have it. Now I want to join this flight delay data, that is the flight delay table, clean table, and flight weather clean table to get a better results out of it. So what I'm doing, see here, select this particular D dot D, nothing but our flight delays, interjoin with the flight weather clean. So I'm saying get all these records from D and join with W, where airport code is equal to airport code, month, day, and the destination hour and hour here. Let's say execute this. So I created a new data frame called, which is a join of flight delays with weather. Clear, everyone? Any question till this point? Let me know. I'll wait for a minute.
Shashank,
Yes.
uh, just a second. Uh,
You're near. You might be near to your phone or something.
no, we are actually
Conference room. Okay. Okay, Swapnil. So, or else you can chat it here, maybe, if it is the case. It is
now.
pausing. Still we're getting it.
Okay. Actually, we had two, three people in the room.
Yeah.
That's why I think somebody's speaker was on or something. That was the problem. So my
Okay,
question
okay.
is, the join that you did using the spark.sql, would
Yeah.
that be a better option to do, or we already have the two data frames above? That joining those two data frames would be a better option. I'm just talking in terms of performance. Would there be any difference? Because we already
No
created
difference.
data frames for the flight delay clean and the flight weather data clean data, right? So
Right, right.
joining data frames as such would be a better option, or doing this in SQL
No, see,
format.
basically everything is an API here again. Even if you use data PySpark data frames or a PySpark kind of SQL API, both are APIs only. This kind of different way. I'm trying to showcase the different ways of using it. That's it. So because everything will go again to a Spark core engine and convert it into required format there itself. So whatever you use it is the same thing there. Not going to impact your maybe kind of your performance, not even by a single second or something.
Okay, perfect. Thank you. Thank you,
Yeah.
Shane.
So it's basically I'm trying to showcase because data scientists might have to work on multiple things, right? So it's better for them to have easier access and understand that we can work on multiple things. That's the reason
Okay.
why we have designed it like this here.
Okay, got it.
Yeah. Okay. So any other questions, anyone? Hope everyone's getting it right. Is it interesting or kind of getting bored off? I just want to know that. So now we are in the stage of data preparation here. Yeah.
yeah, Shashank, this columns which we have joined on, which is the month, day, and departure hour. So, is it like we have, digged in to both the tables and identified these columns, or or will
Yes.
be getting? Okay.
So basically, we
It's
have
kind of.
understood this data set before itself.
Okay. Fine.
So because as we have very less time, right? It is not, we can't go and up and this is generally done by data scientists where he'll go with some correlations and kind of some variances. We'll try to kind of compare multiple with the multiple visualizations. He'll do all these things and then come to conclusion that this is the required column which have to choose it based upon the end
Uh,
result.
Right, but there might be chances, like say this departure hour, there might be little bit difference in the hour of the actual data which is captured. That can be possible, right? So, is there a way that we can figure out or fix that or something? Because this is data cleansing now.
Can you repeat that last point? How they will they miss it?
No, I mean to say in the data, like say CSR departure hour, and we had rounded it to the
Right.
nearest hour.
Yeah.
So both the table, maybe if some delay has been identified, or the rounding off of that hour is coming to like say 1 p.m. or 2 p.m.
Yes.
So if in case there is a chance of mismatch of the data,
No,
right?
the reason why we rounded it is, yeah, what you said is also right. And the other way of seeing it is, maybe if say it as, let's say it is 8.37, and the weather data is giving us 8 point, maybe let's say 8.35 or something. So we are ending up with wrong hour, right?
Right.
So that's the reason why we try to have that. It is small, maybe 2 to 3 minutes delay there, but it's going to impact your condition there. It will not take the results.
Oh, okay. Okay.
That's why we want to make it as kind of round it off to any zone. It can be up or down. We have to round it off to the one point there.
Oh, okay. Cool. Cool.
Yeah.
All right. Thank you.
Okay. Okay. So let's go and see what is there inside this now. This is a right data set. We have it for our data modeling now. Okay. So see here, I have created my data set inside this. It's all given to us, and what are required inside this, and whatever we want to predict it is this one. You want to predict after passing all these parameters. I want to find out if it is getting delayed or not. That's a requirement I have it now. Okay. So let's go down and we save it to a main table called flight delays with weather data. Say execute this. Okay. So I'll go to second one now. So once I have done this, the next step is to see here training the model, right? So we have done a cleaning and everything, and we have exposed it to data scientists. Maybe we can do it, or even he can do it. It is not only him. It can be done by both because we have more control over the data. But he wants to see the patterns inside it, so it's up to them. Or we can both can work together and do it. But this phase is specifically for data scientists. We cannot do it. So see here again, as I mentioned you that they want to predict if it is delayed by 15 minutes or greater here. And so for that process, I want to make sure that the one is nothing but delayed and zero is nothing but you are not delay. Okay, so I want to predict this one. I want to predict this. So in order to predict this, there are a lot of algorithms inside the model. Like we have classification models. We call decision tree, random forest. There are a lot many kind of. So for our requirement, we are going to choose something called as decision trees. So how many knows about this concept called decision trees? Anyone? Okay. Only few people know about it. ये classical, yes, right? So, okay, let me just go in a very high level and explain you what is it doing out. Yesterday we have seen the indexing process, right? If you remember that yesterday we have seen the Cosmos DB indexing hierarchy. The same thing it will do here. Like let's say if the income is less than 30, go here. If it is income is more than 30,000, go to other kind of it will divide it to multiple hierarchies. And let's say a person, if a person, if you want to give a loan to a person, I'll define it as, let's say, if income is less than 30, yes. And then if he is a middle class person or high end person, or is kind of is salaried or self-employed, or if it is having married or not married, so I'll have a hierarchy there. And this hierarchy is helping me out in going deeper and finding out the patterns in it. That's what decision tree does. Decision is that making a decision out of two options, right? Or two or three options. So that's what it does it. Okay, I'll just go in a very high level. Maybe I guess I'll just go touch base it. Don't worry. So this is more about data scientists doing it out. So see here, we are doing some pipelining concept here. Nothing but what is pipelining? I guess anyone can tell. Let me know what can be a pipeline. Anyone? Okay. See, pipeline is basically nothing but like if you see ADF, right? In ADF we have pipelines. Pipelines are nothing but like activities with the sequential process. first you do this, second you do this, third activity is to copy it, fourth activity is to do some transformations, fifth activity is to do DB load. So we're doing some process, right? In the same way, machine learning has got multiple steps of transformations happening out. So we'll do all this step by step, one by one, in a sequential order. So we call that as pipeline there. So inside the pipeline, we have stages. Like for stage one, like how we have activities inside our ADF pipeline, right? The same way, in this pipeline, in the Databricks pipeline for machine learning, we have something called as, so this is inside the machine learning library, we have something called as stages. Stage 1, stage 2, stage 3, stage 4, stage 5, stage 6, whatever it is. Got me right? And other one is one-hot encoding, is nothing but one-hot all these three combinedly. What it is doing, we can go back to our old one analysis. This is what we're doing now. Let's say we have country of India, it's Germany, US, Canada, and all those things. Let's say we have 30 countries here. It defines 30 columns, and each record will be mapped as, is it mapped to which country? That will be enabled as 1, remaining all will be zeros. So it creates multiple columns now. Right? In the same way, it can be maybe it can be married status or not. I can just give it as maybe it as yes and no. So I create a new column called as married underscore yes. Here married underscore no. I'll say here it is, if the record is 1, then I'll say yes, or else 0. So this way I can create all categorical variables. So there's this concept called as continuous data and categorical data. Like example is height, right? Height is nothing but the continuous data. It can be ranging from 5.79999 point something, or it can be even 6.1111 point something. So that there's no limit for it. It can be anything. But when you go with the other one, that is the categorical data, they are grouped into only few limited options. Let's say India countries are maximum of 150 countries, right? Extreme case. Married is 2 options only. Educated, yes or no. Employed, self-employed, or kind of, or service or public servant, whatever it is. We have 3 or 4 options. So this is the way we have a limited structure here. So we can easily define them. So whenever we have something called as categorical variables, we define like this. This is called as one-hot encoding. Okay, this is what we're doing here. Okay, you're getting all these columns and everything. This is okay. Now, see here, what I'm trying to do is, I'm getting the record, select origin code, month, date, all these things from my table, this main table here. And I am also creating, this is a data frame here, and I'm also creating a data frame for columns, right? All the columns are passing into this. Why? I'll tell you later on. Say execute this. Oh, sorry. Execute this, right? Any questions, anyone who's new to machine learning? This is an opportunity to use it. Maybe we cannot go deeper into the concepts, or it is not required for you also to go deeper, but we can try to understand and make it simplified, at least in terms of understanding for you. Okay. So let me know if you have any questions on this space. So I want to read this data, and I wanted to read the data frame and columns here. So let me see this columns now. So I've got a lot of columns here, what is required. That's good for me. I'll go down, and I wanted to find out, the origin code, departure code, and count of, basically I want to find out what is the count of the departures, right? So I want to see how many records are there for each origin and each destination, which are delayed. And this is all nothing but feature engineering. Again, this is physically done by data scientists, not by anyone else. So see here, this is a graph it is showing up. It's showing that Los Angeles with kind of having around 1700 times delayed there, right? It is delayed for the destination airport as Atlanta. Again, Los Angeles has got a destination airport as I don't know what is this already, some location. Colorado, I guess. I don't know. So see this is what it gives out. This all is automatically defined, right? It looks really good to understand this. This is called as data visualization for the data scientist, where he generally understands the data and then come to predictions. He will not directly apply a model on top of it. He'll go through multiple iterations of this kind, understand the data patterns, Like how can we compare both the columns, 3 columns, 4 columns? You'll see all these things inside this and then come to conclusions. Okay, so we can even download this if it is interesting for you. If you want to analyze it, you can download it, or you can even extend this more better. Now, next point is about sampling. So if you remember this point came out here, right? We want to sample this into 70-30 because we want to train a model on a larger data set and test it again if the model is working fine or not. So let's go down. To begin, let's evaluate that kind of data set now, first of all. So first of all, what we want to see is we want to predict this, right? In order to predict this, we want to see if all are fine or not inside this, which means that, let me show you that. If you observe this, the not delayed is around 22 lakhs. Delayed one is only 5 lakhs, right? 6 lakhs maybe. So what it means is if you take a sample out of this, the probability of getting equal is very less because you have dominance of 4 times here, right? Getting 4 times of the ones. So when you take 70% of this data set, we might get more number of records on this and less number of records on this, right? So what happens is with that condition, you will not be able to predict your model properly. So how many got this concept? Let me just, if you don't get it, let me know right away. We are finding the variable which we want to predict it, but we are evaluating if the data set is properly defined or not. Because when you divide this data set of 26 lakh records into ones and zeros and divide it and kind of take only 70% data from it, we will not be able to get all the records here or here because we have large dominance of not delayed than the delayed ones. So when you try to apply your model, the model will more tend to predict the not delayed ones than the delayed ones. Anyone didn't get this concept? Let me know right now itself. I'll wait for a minute.
So we have to go with a lesser number of data set, not 70-30, but
then what is the guarantee again? What is the guarantee that it will take it off? So what I can do is, maybe I can take 70% of this one, right? Sorry, I can take only 30% of this.
Yeah.
Right? So I'll get only 30% of records from here, and anyways I have 30% here, so it becomes more easy for me to map it. So see here, I'm just defining the fractions, saying that from 0 take 30%, from 1 take everything, and I'm defining the fractions here. Sample by df_release.sample by this particular system. And what is this one? Can anyone tell me? This is called as seeding, random seeding. So can anyone tell me what is seeding concept? It's more about common sense. Just kind of think of it. Anyone knows about means?
Generating numbers randomly, picking the data randomly means 36
Yes.
means a particular range.
Exactly right. This can be any number here. It can be any number here. What it means is, let's say when you're sampling it, it generates some records, right? So it generates some fraction of records, right? So from that data set, what is the probability that it is taking randomly all the records here? So if you see example, let's say I'll go here. So let's take the example again. Let's say I have 1,000 records, and I'm saying that I want to take 70% out of it, which is nothing but, let's say, 700 records, right? So next time again, when I go back and I execute this code, it will take another 700 records. So this is the version 1, first time when I executed it. Again, it takes 700 records from this dataset, which is kind of version 2, which is nothing but this data and this data is not same, right? Because I'm taking random data. I'm not taking the static data there. Sample by random, because this is by default random. So what happens when it is random, you will not be able to take exact same data set always. So in order to have a same data set, we need to have a hash mapping, right? We need to have a key value pair, saying that whenever I give this key as 36, take the same data set what you've taken last time. Clear everyone?
Shashank, no, I didn't get it. So you mean to say that why you are doing this? Because you want to train the model on a random databases, right?
Yes.
Correct?
Yeah, true. So basically, I want to take the random data, right? What 30% means here? From this data set, I want to take 30%. From 22 lakh records, I want to take 30%. So how will it take? It might take first 30 or last 30 or middle 30 or maybe first 15 and last 15. So it can take any way, right? Sample is something which is kind of taken randomly. So I want to make sure that whenever I execute this, every time I execute this, I want to make sure that it takes the same data set always. So I'm mapping that whatever we're taking now, right?
No,
The
whenever
first
you
time,
run, you will never get a same data set, right? Because you are getting a
no.
random data.
Yeah, we're getting random data for the first time. Okay. That data is mapped to the variable called key called 36.
Yes.
So next
And
time again I execute it, again I'll take the same data set called 36. Same records, whatever we have taken the first time, right? Take the same thing here. First time is random one, okay? So we have got 700 records. So when I say seed equal to 36, it is mapped to this. It is mapped as like version 1, 36. So next time when I say again execute the same record, I will say I'll give you same V1 because it is mapped to 36. I'll give you same 700 records.
now I'm confused actually here why it will give the same record, because you are doing a random data generation.
No, see, random data generation is first time, right? This is the first time I'm doing it. Okay? I have 1,000 records. I'm taking 70% of it. I got 700 records randomly. This is randomly generated, right? First one. Now, this is nothing but when I got 700 records, I mapped to a variable called 36. This is called key, maybe. So this is a value for it. Clear for till this point? Lay over
Yes.
this. Lay over this point. Okay. Now, as this is a daily process, this notebook is a daily process notebook, or this can be reiterated. Maybe I'll go back and reiterate it. So what happens is generally, it will generate another random 700 records, right? So what I'm saying is, yeah, anyways, first time I have done it and I have mapped it to 36 key column. Okay, so even next time I execute it, it will first go to 36, find out if there's any data in it. Okay, I have some data, map that to it. So again, it will be 36 next time also. Got me?
Okay.
So any time you execute this, it will be same number of records. So what happens by this? We will not have any impact on your training output, because you're training data, right? When you use this set, it might give you, let's say, 83%. When you use this, it might give you 56%. When you use another again execute it once again, then it'll give you different version. So when we have same data set, same number of records, and same kind of records, it always gives you 83%. Clear?
Yes, it will always give 83% whenever you run.
Yes. Yeah, that's
And
what
that
the
is the
intention is.
objective, right?
Yes, that's the objective.
But why
Take only same
that is
number
the
of records.
objective? But why that is the objective? Because you have to basically train the model in such a way that if data changes,
Yeah,
it always gives you same output, right?
right. That is the second stage of doing it. First stage is
Okay.
initially building a model with the right, at least some sample data, and build a solution. Again, go back and iterate it. This is all coming into this stage. What we are talking about, what you're talking about is this stage. Coming to final model,
Yeah.
where we have to go multiple iterations again, all those things.
Okay. I was actually confused at that point that why you were doing this.
Oh, no.
Yeah. Okay. Yeah.
This is the stage here. Yeah. So I have a group by condition here, and I'll say count of this record. So let me execute this and try it out. I'm taking some random 30% records here with a fraction of with a random seed as 36. So now see here, it's almost close, right? 5 lakh, 6 lakh, and 6.8 lakh. So 1 lakh difference is okay, right? So now if I execute my model on top of this, it gives me better results. There's no bias on top of this, right? There's no bias, because both are almost equal in number of records, so it will train in a proper way. Now, we have our data ready now. The next step is to select an algorithm and transform the features. Okay, so as I mentioned you, we are using decision tree algorithm, and this can change out. See, this is not a one-time process. It will change. Like we can use binary classifiers, random forest, or let's say kind of XGBoost. There are many algorithms inside the space. So it's up to the data scientist. He can go multiple iterations. He understands when to use what, and he'll go with that. Okay. Other point is pipelines API. As I mentioned you, this is nothing but streamlining your process. Like first do this transformation, then do this, then feature engineering, then execute the sample data, train the records. This is sequential steps happening out. Okay. So we'll do all these things in pipelines. The two things, we're selecting the algorithm. This is the nothing but decision trees, and we are going with pipeline approach, which is nothing but doing a sequential steps, which is called as stages. So what are we passing in to get the records? We're passing all these columns: origin, airport code, month, day of month, all these parameters into my algorithm to predict the value called it is delayed or not. Right? When I pass all these things, it should tell me if the algorithm, if the departure delay is 15 minutes or not. Clear everyone till this point?
And that algorithm will be that we need to define, and it's like a already model present in Python.
No, see, it is already present in Python. We have to use it.
And how we basically decide like which algorithm or which model we need to.
Yeah, so basically there's a lot of concepts in it, like kind of you want to have a faster algorithm, or let's say you want to kind of have a deep dive into it. Kind of it's basically there are a lot of parameters, like kind of it is classification, regression, or kind of and again if it is the depth is hierarchical or not hierarchical. So there are a lot of parameters to choose it. I guess we cannot discuss that points here because we don't have enough time. But maybe I guess we are starting an AI course very soon. I'll share you the links. Maybe you can just testimonial me, or you can just add me in the LinkedIn. I'll anyways post it in the LinkedIn. The Global AI Bootcamp that is starting on 24, 25, 26, 27. We'll touch base on that space. We'll touch it on all those things there.
Okay. Yeah.
Yeah. But I guess because we don't have enough time there to go into the concepts of machine learning and deep learning here. So, but in a higher note, yeah, they know how to decide it, right? They've been doing that for many years, so they can do that. So what they decided is let's go with that. But they even consider one more thing called as one-hot encoding, right? To convert all categorical variables into binary vectors, which means that the same answer here, what we discussed here. Whatever categorical variables like this, we have categories we have it will be converted into like this. Whatever categories we have it, converted into this. Clear? So that's what we are trying to do here. Okay, this is a stage one. Okay, let me just go and show you that. So categorical variables are three here: origin, airport code, carrier, departure code. Let's go and see that. Origin, airport code, departure code, and carrier. These three are categorical variables, right? So let's go and I have defined it. See here, defined a list called categorical columns. This is the most important thing. See here, I have defined something called as stages also. What is stages? Nothing but your pipeline stages, like for the first one, second one, third one. So this is nothing but list here. So first what comes in the list, second what comes in the list, third what comes in the list, it will define inside this. So we'll keep on appending to this. Clear everyone? Okay. So now I'm taking each categorical variable from the for loop and saying that I'm converting this into one-hot encoding here. This is all nothing but one-hot encoding. And after converting into one-hot encoding, I'm mapping that to my stage list. So this is the first step I want to do it. That's what I'm mentioning here. The same way the departure DEPT is also categorical variable, right? So I'm even converting that also to a like this here. I'm saying here DEPT del 15 underscore 0 and DEPT del 15 underscore 1 as 1 here. So if it is 1 here, it will be 1 here, it will be 0 here. Or if it is 0 here, it will be 1 here. Right? So this way I'm defining this solutions here. Right? Any questions at this point, anyone? And I'm saying again map this to the second step. First step is to convert my categorical variables, and second step is to even convert the variable which I want to predict it. Okay, so if you see here plus, nothing but appending to it. Okay, so I'll execute this step now. So some might be confused here, maybe because they are very new to this concepts and all these things. It's okay because this is all done by data scientist. We're just trying to leverage this model. Now, after completing all these things, I create a model called dot model file, dot pickle file, so whatever it is. So that is what we want to kind of take it from there. Okay, let's see that. Numeric columns. So again, there are two things, right? One is categorical, and another one is numeric, or kind of we call it as continuous data. This is all continuous data sets. Okay, and I'm trying to define them also. I'm trying to append them also into stages here. So the third step is to kind of take them also into the loop, basically appending to the data set. Now I have my data set created. Now what is the next step? I want to train my decision tree model. Okay. So in order to train it, I have to divide my data into two parts: training data, testing data. So I already have a sample with me, right? From that, I'm saying that take only 70% as training data and 30% as the test data. And see here again, I mentioned seed equal to 100. So again, out of this, I want to take only every time static one. I don't want to recreate every time same thing. Clear? So then I'm creating a new data set again, new data frame again here, because I want to reiterate this process. Maybe a couple of different iterations. I want to try it out. So I want to keep the original version like as it is, and I want to train on this versions multiple times. Okay.
Yes.
Hello.
Yes, I'm able to hear me.
Yeah, I'm able to hear you.
Yeah. If you seed value, you need to decrease it, right? So that we'll get the appropriate values at model level.
Why decreasing? It is a static value, right?
No, if you take 100, it will take 100 samples, right?
No. That's not epochs. Because you're saying about epochs. Epoch is different, seed is different. So see, basically seed is something where you're taking randomly some 70 records, let's say for 100 records we have it inside this. So I'm saying that 70 records should be mapped to training data, 30 records should be mapped to testing data. And seed is 100 means is that I'm defining the 70 records as static ones. Whenever I execute it, again it'll take the same 70 records. It will not take different 70 records. Okay.
So you mean to say out of 100 records, you take 70 from training and 30 from test. That's what you mean to say, right?
No. Out of, let's say, see, this is what I'll tell you this. Let me copy this record. You might be confused, it's okay, but I'll just try to again explain it again. This is what we're doing here, right? So what I'll do here is, what I'm mentioning here is, I'm saying that for train, let's say we have 500, let's say we have 1000 records, okay? Let me just say it as, okay, let me just say training sample, okay, has got 1000 records. Let's assume that, okay? I'm saying that give it as 70% for training and 30 for testing. So training will have now 700 records and testing will have 300 records, right? So now this is the first time I'm doing it. I'm mapping it to something called as versioning. So seed is equal to 100. So the first time it creates some 700 random and 300 random, right? So it automatically takes every time the same thing. Now even you again execute it, it takes the same 700 records. Clear?
No, that's what I mean to say, right, Shashank? Every time means it means it is giving a percentage of amount of data which is taken, right?
Yes. I guess there's something missing out here.
Yeah, based on my understanding, seed 100 means it's kind of percentage, how much training data we need to take and how much test data we need
No. Seed is nowhere linked with how much percentage you take it, right? Random split of 70 and 30 means, right? You take 70 records for this one, then 30 records is passed to this one. Okay, and seed is something where we have static defined, as I just saying randomly, right? So next time when I execute it again, so let me do another question for you. When I execute this and say execute, okay, it is created now. It is creating me 700 records here and 300 records here. Okay, again I execute this. Maybe again if I go back and try to modify something and again I say execute this. It takes again. It'll take what will be passed here? Will be same record will be passed or new record will be passed here?
It depends because it depends, right, Shashank, actually, because we are taking, we are considering all the data set.
Yeah. So it should not depend because I want to make it static. So I mentioned it as some random value. You can even give it as here 10 also. What does no one will ask you? You can give 35 also. So you can just some random value which will help you out. Generally we go with like we go with 10, 20 and all this. Like it's nothing but number of iterations. We do it. So based on like let's say you want to do train on some data set and again go back and train on second data set. So you will do these iterations here, saying that seed is equal to 10, which means that this is a key and the value for this is exactly mapped with this way. That's what the seed means. Whatever you are referring to is the epochs, number of epoch trainings.
Okay.
Yeah. Okay. So here I'm executing the count here. I'll say executed. Just 2 minutes, guys. We'll complete this and we'll go for the break. So now see here, I have my training data as around some 8.9 lakh records, and here I have around 3.8 lakh records. Okay. So then I'll go down and see this is what I mentioned, right? I'm using the algorithm called decision tree classifier. Okay, and the labels features I have already defined them, and max this is called as hypertuning parameters. Max depth is nothing but max depth is nothing but you are using kind of how many depth levels you want. Let's say you want to give a loan to a person, right? So you're a banking manager, so you want to go kind of give a loan to a person. Okay, so what you will predict first, you will see if if this is kind of getting income or not, yes or no. If it is yes, he's in the low range income, high range income, or middle range income. If it is, let's say, if it's in the middle range income, then he'll see that if he has got credit score better or not before from previous transactions, previous loans. So if it is good, then again go for the good section. So you're defining a hierarchy here, right? Right. This hierarchy is defined here. That is nothing but depth. Depth is the number 3 means that it will go for 3 levels of depth. That's it. And beyond that, it will not go. So we can define the depth here. And it will take more time to define. Let's say you give us 4 here. It means that it's taking around 4 levels of depth. It will give you more better results, but it will take a longer time to execute this. Okay. So now that is done. Next one is I'm adding my last step as decision tree algorithm. Right. So let me go on up and tell you what all the stages we have done it. So just go up. I define multiple stages, right? Let me just go down. So first stage 1 is this one, stage 2, right? Stage 3, and then we go with last one as stage 4 as the algorithm what we are using it, appending to this stage 4. So now see here I'm saying create a pipeline with this stages of 4 stages here. Clear everyone? This is the input parameter. The value for this is stages. Okay. Now when I say stage, it will create this sequential pipeline for us. And then I'm saying that fit and transform this model. Fit is nothing but fitting into the system, into the algorithm, and then transform all the features, whatever we want to do it. And then we are finding out we are taking only 2 columns from this. That is labels, features, plus all the columns. So let me execute this. It's okay, even if you don't understand it a little bit, it's okay. Just kind of assume that we are trying to build a model. We're trying to use our trained data set to train the model with the decision tree concept, decision tree classifier. That's it. Don't kind of think in a very high level this way. You just see the questions now. So I got a few questions that don't know. Yes, Kislian, so that's what is really right. And do we have same data for different run? No, we'll not get same data. We'll get the same data sets. Stages, I guess. Call user 3. I'm not sure who is it, but you got the answer, right? Why we have to use stages, add stages, because we're trying to execute each step in a pipeline here. So now we are done with this. So now we are able to see the stages here. These are stages inside it. These are the kind of parameters we have it. Okay. So this is what is giving you output here. Let me go down, and now I wanted to do. I have trained my data set, right? Now I want to see the prediction outcome of this. So I'll see the prediction outcome. I've got a prediction outcome here because I've trained my model and now I'm testing on my testing data. Okay, so I'll see the prediction now. Let me just go down, and there's something called as binary classifier. I'll touch base this concept later on. I'll say evaluate this model. See, now I got around 63% accuracy. Okay, let me go up. I'll go up. I'll transform the depth to, let's say, 7. It might take a little time for us, but it's okay. Oh, it's already defined. Huh? Okay, then we can't change it out. It's okay. I guess we have to remove all these things and again rewrite, but it's okay. Yes, you are using the concept that it is 63% accuracy here. So now I guess we understood this concept till this point. Let me just go back and again tell you a few more things. Now we have done the training model, right? We have done this point. We have applied algorithm. We got some accuracy of 63%, whatever it is, on training data, so testing data also. And again, see the 50 point, right? Iteration and hyper tuning. So we have to again iterate this process because to get a better modeling. And hyper tuning, as I mentioned, right, changing the depth of it, right? Change the depth to first I'll give it as 1. Max depth is equal to 1 here. Max depth is equal to 2, 6, 10. And bins are nothing but again the parameters are kind of root nodes we call it as. So we are giving that also here. So these are all nothing but hyper tuning parameters for your classification algorithm. So I'm doing all these things. I'm creating grid of it. So what grid means is I'll say here, let's say 1, 4, 6, 10, and I'll say here what is the other one? 20, 40, 20, 40, and let's say 60. Okay, so now I'll say here a combination of 20 comma 1, 20 comma 4, 20 comma 6. So I'm defining these parameters like this, and I'll pass these parameters into my algorithm here, into this. How we're passing max depth, right? The same way we pass even our bins also. So what happens with this? It'll go through multiple iterations, multiple kind of hypertuning parameters, because this all has to be done by the data scientist manually. Instead, he's trying to build an algorithm which will do automatically and give you best results. So he's doing that here. Add grid and build. So when I say param grid, now I pass this param grid into my pipeline like this. So I say cross validator and get the records now. We'll take around few minutes to do it. It is 2 to 3 minutes, I guess. Once I get this, it will give me multiple model sets. What happened to this? Column prediction already exists. What does it mean? Some problem, guys. This. We try to change this and again go back for it. Something went wrong in this.
Shashank, just a suggestion.
Yes.
Can you check the target variable name is already existing by the same name in the training data?
Oh, is it?
Maybe I'm just trying to suggest.
This is the last one, right? This is the last one we created. We didn't take that. We take it the last step. But let me go down. Label features. Certain columns here.
Maybe we should remove the target variable from the training data set.
No, we didn't use it at the train data set, right? We just used certain columns is nothing but only this columns, right?
That is label and the features and plus
Oh,
calls.
right. Calls are using it. But yesterday night I executed this for whole code. It worked fine. I think so. That should be the issue there. Yeah, this is what output column label already exists. So maybe it is already trained, right? This column is already trained out, so it is giving you training data. What is training data here? Yeah, it is containing this. Should have it. It's okay. So what training data means is data 2 here. Yeah, we even have it here. So people who wants to go for break, they can go for break. They can come back in 15 minutes. I'm just trying to see solve the issue here. Okay, so pipeline here, I give already given the value, so it's taking up there. Maybe I'll remove the state and cluster removes here. Execute from scratch again. Should not be issue actually. It's done here. It's going fine, I guess now. So maybe some record which we might have missed it out somewhere. It's going fine
It
now.
is not fine.
Yeah, it's going fine now. I just kind of cleared a cache and again ran it.
Okay.
There's something which we might have missed out, some stuff which we might have missed out in the middle.
Shashank, this cross validation means we are running the model on the same data set, but
Yes.
on different subsets of the training data. I mean, we are
Yes, kind of, yeah. What is it is right, and also we are trying to go through the multiple hypertension parameters.
hypertraining. Okay. And among these, we will choose the best one.
Yeah, like example is like this. If you can see here, right? We have 20, 40, 60. We have 1, 2, 6, right? It takes up these two
Yeah.
parameters and kind of creates a model out of it and try to test it out. Second one, third one. This way it'll have a complete grid of this. So it'll do around 1, 2, 3, 4. and it will go for 12 iterations now, and gives you the
Okay.
best model out of those 12 iterations. You can even have many more, but again, it will take more longer time to create a model there. That's why it is taking more longer time here.
Okay.
Yeah. So if anyone wants to go for break and come back, it's okay. You can go and come back. We'll see after the break. I hope anyone, you don't have any questions till this point, anyone? And just assume that I would say better to consider if you're very new to machine learning or if you're kind of not known to it. It is very difficult to explain all these things in short time, but I'm trying to make sure that you understand the concepts. You can just assume that we are trying to train a model and getting the result out of it, and that the model can be exposed to your machine learning workbench. Okay. So let's come back after the break. I'll just take around 10 minutes break, 15 minutes break. We'll come back in 15 minutes. Okay.
కంప్లైంట్ రైజ్ చేస్తారు ఇండియన్ రోడ్ ఎప్పుడు ఎందుకు 3 సార్లు 4 సార్లు రైజ్ చేశారు క్యాప్టెన్ ఏమని ఫుడ్స్ అంతా ఏదో తినచ్చు క్యాబ్ జమ్మిన లాస్ట్ మోహన్ చెప్పేస్తున్నాను హలో 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 హలో
daily.
Hello. Hope everyone is back. Just go to the question section now. Thanks, Hina, for your comments. It helps a lot. So I have a question related to Gen 2. Can everyone keep the post in open everyone mode, because everyone can understand what questions you're asking, because it will be for me to repeat it again and answer it. So yeah, there's a question from call user 3. I don't know who is it, but a question related to ADLS Gen 2. How can we use REST API to create a file system in ADLS Gen 2? Create file system. So you want to kind of create a file inside it, or you want to kind of create a structures inside it? I'm not really sure what you meant it. Just elaborate a question so that I can respond to you. Maybe I can mail you out by today evening, because I don't have it handy anything on the space, but I can just mail you out. You can just elaborate a question so that I can respond back to you again. Yeah. Okay. So yeah, now I guess we are able to achieve it. It took me around 5 minutes to complete this process, and now the model is created. So what does it mean? What does it mean? It basically goes through multiple iterations like this. It first takes out these two parameters and builds a model out of it, and then this model, this model, this model, like this. It kind of goes with 12 iterations, right? 12 random iterations, and then comes out with a solution of this. This contains 12 models now. Okay. Now I can say transform it. What it means is it takes the best model out of it. Basically, it'll apply this dataset on best model and gives you the results. Let's see the output now. It might take again a few more minutes. And the this CV model uses the best model for cross validation. This is done now. So I want to evaluate the model now. It is 62.08 only still, which means that we already use the best model there, right? So we'll say, one second. Sorry. So now I'm selecting the right model into it, and I'm selecting right values. So it gives me here the kind of label, and prediction is this one. So the label is here, the prediction is this much. So I'm giving all these values, and for the origin code is this one, and the destination code is this one. So I'm just giving the analysis here, right? So now I want to take the best model out of it and map it. Like I'll say CV model dot best model, and I want to apply this best model on top of this. So execute it. So now we got a model now. It is giving me 62.16 now. It is compared to older one. It is quite little better. Yeah. And now this model I have to save it. So this is the role of a data scientist to save this model in some location. So I'm saving, this guy is saving it in the DBFS path, right? So save this model, it creates a model of this kind, flight delay dot model. This will be stored inside your DBFS layer. So now from here, it is our responsibility as a data engineer to get this model file and train and kind of push it into your Azure storage account. Okay. So let me go to the third space now, deploying as a web service. Okay. So before going to this, I want to introduce you this concept of Azure ML SDKs, okay, and Databricks clusters. So yeah, the question came out that first thing is the reason the early edit is, I don't remember the name who asked it, but there's a workbench which has been there from long time, but it has been kind of deprecated, right? Actually, machine learning is deprecated. That's a good thing because Azure realized it very faster that there is an issue with this because they create an framework for making your machine learning models easier. That is very good. The thing is that every company is in different stages. Let's say a company who is already matured enough, they're already building their models on top of something else. Now they cannot use this framework, right? Or company is already in middle of building something. Maybe they're kind of maybe beginners, or let's say kind of early adopters who are trying to build the systems with the another systems. Like kind of they're already using some Jupyter notebooks, or let's say some clusters, Spark clusters. So they're already building these machine learning models on top of something. So they cannot embrace this framework. Maybe the people who are very new to this, they can use it. So now this framework is fitting into only one small space of audience, right? That's nothing but beginners. And a few little scope of having it in the middle level, but nowhere in the matured state of users, or of the clients. So they're not able to fit this framework because it's a framework, they're not able to fit it. So they thought, let's remove the framework completely. Let's exhibit this as an SDK. So where this SDK can work on any systems. It can be a matured AI team, or it can be a novice, even in a kind of, it can be a very early adopters of your machine learning or deep learning models. Anyone can work on this because it's an SDK, nothing but a libraries. They can directly use it instead of using a framework and trying to build everything from scratch again for the people who already implemented it. It's better to work on SDK than extend their existing models. Like see this one. Before this all has to be done in the framework, all these things. Now I can do anywhere. I can do it in Databricks and directly open up this inside my anywhere. I can use it anywhere and start working on this space. Clear, everyone? I guess I answered the question for someone who asked me about this question. Akshay, right? Akshay, is it you? I don't know. Okay. So this is the reason for yeah.
Would it be possible to share the Git URL for these files?
Yeah. I guess we've already shared it, right?
The import URL.
Okay. Import URL. You want to have it? That is. What's in the Jumpstart Ninja? This might be the one, not this one. Sorry. Go to day 7, right?
Yeah.
You'll find big data.
Okay.
Hands-on. The hands-on, you'll find lab files. There you find DBC file. This is a path for it.
Okay. Thanks. Yeah.
I'm just putting it here so that everyone can use it.
Yeah, sure. Thanks.
Yeah. Sure. So open up better. This is a better one nowadays. Ignore the first one. Take this second one. Directly copy paste it. Okay. So now let's enter into the documentation part of it. Like kind of why are we doing this now? Okay. So we understood till this point, right? What did we do in this process? We created the we prepared our data, and then we trained our data on an algorithm, right? We have done different stages for it, and then again tested with the testing data. We found that the accuracy is a little less, so we went with the concept called as cross validation, which will kind of validate all possible hypertuning parameters. Then we found that it is a little bit improved, so we want to consider that as of now current model. Maybe we can improve it a better way, but as of now we don't want to concentrate on modeling part. We want to concentrate on how do we deploy it and how do we maintain it, because that's our duty, right? So whatever the data scientist gives you as a kind of dot pickle file, model file, whatever it is, that should be exposed to your machine learning workspace. Okay. So now I'll ask you a question. So yeah, I created a model now, and I am a data scientist, and you are all data engineers. Okay. So or DevOps engineers. So I created a model and gave it to you. Later on, again, I want to go back and see what model has been giving me best results from past 6 months. I want to go back and see let's say out of these three models, what is the best model? Or I want to even make sure that I have created a new model which is giving me best results in my testing data. So I want to expose it into my real-time production environment. So I want to put this model file in some location. If you observe, this is a iterative process and this is a kind of continuous process. It is not just one-time process, right? It continuously happens out. Let's say generally what happens is every 1 month or every 2 weeks or 1 week, we're trying to retrain our model and send it out, which means that we get a new data, right? Every day we get new data in a batch process or let's say in a real time. So this new data is again trained and tested and found out if the same model is giving me better results or same results or not. If it is reducing the accuracy, then immediately we'll change the model. We have to try to again fine tune this model because for new data it is not working out, right? So we'll make sure that we retrain the model, reapply different algorithms, or we go with different hyper-tuning parameters, cross validations. They come up with saying that okay, this model is giving me better results. I'll take this. Okay. Then again create a new model and give it to my data engineering team or DevOps team. They'll maintain it again. This is a continuous process. This will not be one-time process. This is a continuous process. So as this is a continuous process, we want to validate this and we want to maintain this code or this models, these versions. So maybe the same model can be kind of given a different version for it. Maybe a little optimization you have done it and created the same model with a different version. You want to maintain that. Or you want to try different algorithms and then come up and say that we have three models with three algorithms. I want to work on all those things. And then you can say that out of these 3 or 6 models, I want to make only one model as a kind of production ready model. And this all is a kind of iterative process and this is all continuous process. So in order to handle that, we don't have any specific kind of system which can do it, right? This came out around maybe I would say 2 years back, but later on they realized that it is a framework. Framework is not fitting into systems. Then they went with changing this process. They gave the SDK here. Okay, so in this SDK, what does it contain? Okay, so before that, I'll just go and show you in a very high level and execute one by one. Okay, this is an SDK library. This is called Azure ML Core. Okay, and first of all, what we do, we create a workspace, nothing but a higher umbrella, like how we remember that event hub namespace, right? Or subscription. Under subscription, we have resource groups, right? Same way, we have Azure ML workspace. Okay, it is created one time, and under that we can create n number of experiments. Under that we can create n number of models, compute powers. So you can define all these things manually. So I'm giving my subscription details here, my workspace name, my region name. I'm giving out everything here, and then what I'm trying to do is I'm creating a workspace here. This is all input parameters. I create my workspace here. Workspace.create. I'm giving all this subscription, all this details. So it creates a workspace. You can go to your this place and try to see that out. We'll see that. Okay. It creates a workspace for us. The first step. Second step is to persist this configuration. What it means is I wanted to reuse inside my Databricks. I want to reuse this inside my Databricks. So I want to make sure that I am pretty sure that this particular model should be persisted inside my Databricks account so that I can reuse this subscription. I don't want to always go to this Databricks, the ML workspace, get the requirement, like what is the subscription, what is the resource group, I don't want to get it. I want to have it in a config file. So I create one file called write-config, that is nothing but config.json file. When I say ws.write-config, it creates a file inside your AML config that is giving you config.json file. I'll show you that also. Okay. Inside this will contain the information of subscription, workspace name, resource group name, and all these things. Okay. So this is what it looks like. And then, okay, then this all will come back later on. Then I'm deploying this into container. This is what I mentioned, right? If you are doing it, there are two things: containers as instances as well as Kubernetes instances. So can anyone tell me what is the difference here? Any guesses of what is the difference between Docker containers and Kubernetes? Anyone who is already working on that?
It's a difference in the orchestrator, basically. So in Azure Kubernetes service, it is purely hosted by Kubernetes, and it's a managed Docker hosted environment, I would say.
Yes. Yes. But what is the huge difference there? Like kind of why do we go with production only with the Kubernetes and not with Docker containers?
The auto scaling.
Yes, exactly right. At least in terms of, yeah, maybe it can be for web apps and different things, there's a different use case. But the main intention of having Kubernetes into production environment is that we make sure that the REST API is scalable enough to handle anything. So to have that, we should have better Kubernetes system which can scale up and scale down automatically, which is not possible in container instances. Okay, so and again, just to people who are very new to this Dockers and everything, this is nothing but a VM logically. I mean, just given a very high level, it's not the same. But in the VM, we contain all the OS, all the unrequired files. See, we want to build a VM only for deploying a product, right? Which is logically not a right way to do it. Till a few years back, we only have an option to go with VM. But now we have something called as Dockers, a kind of way where you can try to define your configuration. Let's say I want to have 1 GB and of one compute node. I want to build a logical VM where I can only have required libraries into it and I can execute my code. It's only for that. Okay. So why in terms of machine learning, why Kubernetes and Docker and KV picture is, first thing is we don't need to worry about the version control here, the kind of the version, let's say Python or kind of let's say any library is using some older version in dev environment, and when you move to production environment, you have to install everything, and you find that that is giving a different version, a model will not work, right? So this all issues we faced it, and then they realized that okay, let's go with Dockers. So that's the reason why we went with container instances here. So what does it contain? So first of all, before using containers as instances, let me just go down and first of all register the model. As I mentioned you, we can register the models inside the Azure machine learning, which means that let's say model 1, model 2, model 3. I'll define multiple models, right? So as of now, we have the best model with us. So I have to register this model into my machine learning here, which I'll do it here. Okay, I'll tell you this. We'll go deeper concepts like model.register. We'll give the model name for it, and the kind of the model name again here. And so this is the default name. This is the name what you want to give it, and this is the description. This is the workspace where you want to define it. Okay, and now then once I've defined the model, I want to create my web service. Okay, let's go till this point and come back again. Okay, let's go up. Let's start creating it. Hope everyone is clear till this point, right? No issues, no questions. Let me know now itself. So I'll just say test this. So this is not there, right? So let me just go here, see this, upload this in a py pipe. So where do we do it? Just go to your clusters, open your cluster. You remember this, all this one, right? Install new, go for py and say this is a package name and say install. It will be installed in a few minutes, maybe a half a minute. In the meantime, I'll take the questions. Right, Kishli, it is right. What you said is right. So I guess we have another 1 hour. We should be able to do it. We'll complete by 12:15 logically. Yeah, it's installed now. So let me just go to my deploying model web service. So I'll just now execute this to confirm if the model is created. Yes, I have 1.0.41. It is created now, right? Now I'll say initialize AML workspace, as I mentioned you, right? But here we have to define the subscription names. So let me go to my subscriptions here. This is subscription ID. See here. Copy this. Go here and paste this off here. And the resource group is different, right? It has end-to-end RG. I'll copy this. I'll paste it here. Okay. And the workspace name, I will say AML-workspace. Okay. And it is in the used US2. And I'll say execute. This is the kind of variables I created now globally. And then I'll go down and I'll say workspace.create with the name what I gave it here, subscription ID and all these things, and x is equal to true. So when I say execute, it'll ask me for authentication because I'm trying to do it from third-party instance. It'll ask me to authenticate. So I'll copy this URL here. This is only one-time activity. I'm doing it from the external system, right? I'm trying to access and create something from my different account, not from your portal. So it'll ask you for the first time to authenticate that you are doing it from authenticated systems. Say next. So you'll be done here. It'll asking me this is the one I have it. So it is completed, right? Now let me go here. Now see this, it will start working out. Authentication successfully completed. Now it starts creating the workspace and everything inside it. It will take around half a minute. Deploying, see this, storage account with the names. It creates a storage account for having the logs of run models and everything. It creates a storage account there. If I'm going a little faster, let me know so that we can help you out in whatever possible ways you have it. In the meantime, any questions, let me know. See this, it is creating all those things, right? Key vault, storage account. Insert is created. Key vault is getting created now. Now see, last one is deploying the workspace. It's creating everything here, right? So anyone working on computer vision in this space? Anyone here? Okay, that's fine.
We are working on some intelligent character recognitions and all.
Okay.
For some paper to automated processing, but not exactly the vision as in some driverless car or something like that.
Oh, okay, yeah. But that's the same thing I'm referring to. That's okay. Computers in a failed state. Try creating, recreating it. Why? What happened to this? Oops. Again, have to recreate it. Huh? Let me rename it. Maybe there's some issue with the naming convention here. HOL workspace. Let me execute this. Some problem with this again. Few minutes. It takes around few minutes to complete it. So just to update everyone, there's a global AI bootcamp happening out from 24th till 28th. That is 4 days, 3 hours each. So if anyone is interested to join this and learn more about the advancements in this space, more about using this machine learning studio, machine learning notebooks, and then using the deep learning models and integrating with the cognitive services. So those things, if you want to know it, then this is the right opportunity. I'll be delivering it again. So it is open to all. I'll be sharing the link to maybe Lata. We didn't get yet. It is still pending with Microsoft. Once I get it off, I'll share it out with everyone so that you can leverage that. It's a free of cost kind of. So anyone can join it off. Anyone can join the world.
Yeah, Shashank, please share that with Lata.
Yeah. Sure, because there's a new advancements coming up like Azure ML Studio V2 and even the notebook servers getting created, Jupyter notebook servers. So you can see all those things there. Maybe take a little time to create it. It's about to complete now.
Shashank, do you have some standard figures on adoption of AI services on Azure versus AWS versus GCP, where the industry is going?
Okay, so just to update at that point, the industry is still in the open source approach. It is not yet because they don't have these tools yet available in the market. Even if you see SageMaker, they are also going the same approach. There's no difference in it. Whatever we are seeing now, they're also going the same approach. But this came out and this has saw a lot of issues in it. Kind of this has been resolved in Azure, and they came up recently. SageMaker came up maybe around 6 months back, right? 6 7 months back. Kind of it is very early to say about AWS, but GCP is strong enough in data modeling and kind of designing the right models and Kubernetes deployments, that space. When it comes to enterprise scale, I don't think so. GCP is kind of enough stable enough in terms of enterprise scale. It is very early to say about it. And I would say SageMaker can pick up faster, maybe based upon the bandwidth and based upon the availability of customers. But Azure, I could see a lot of people involving more into studio-based approach because there are more about business analysts and kind of more into that space. So when it comes to machine learning services, as of now, people are kind of tending towards having their own Jenkins accounts and CVS accounts and then mapping automatically, mapping their deployment models and everything. So they're defining their own CI/CD pipelines, and this can be a kind of breakthrough for them. But still, I'm not sure if they can adapt to it or not. So that's a high level thing I can answer it.
Thanks.
Yeah. Okay. So provisioning completed here. So you can just go to your portal and see if that is created here. See this? This is the one workspace we call it as. Click on this. So this is what it looks like. We come to this point, what are all these things going forward? But let's assume that this is created now. Okay. Let's go back to our systems. Now see here, I'm trying to persist this into a file called config.json. I'll say execute this workspace of the workspace name and passing all these parameters into the system. And I say execute the JSON file. So it will tell me what is subscription name, what is the resource group name, what are the providers for this, what is the workspace name, and all these things. Okay, it will have this information in a JSON file. Now I want to copy this config file from local to DBFS. Okay. So I'm just defining that path here, .cp from local to DBFS. Let's see, local is nothing but file path, DBS for path, I'm pushing it off. Okay. So that I'll have a global variable. I don't need to worry about always about this because it will always be there. Even if the cluster is off and on, it will be there. So now the next step is to deploy it into container instances, right? So I'll just define my pipeline model here. Okay, now, again, I'm copying from model from DBFS to local instance. Locally here, I'm creating it here. See, basically, when you're registering a model, right, you want to have a configuration defined. So I'm again kind of taking control over it from my DBMS path always. I'll say move into this path, and then and now here I'll say I want to register the model. So in order to register the model, I want to get a configuration, right? I'm getting it here. Okay, and here see this, I'm registering the models. I'm saying that model.register. What is the model name? That nothing but it basically points to a local file folder or current working directory. This is nothing but the real model name. What model name you want to give it? You want to register with. So I can say same name I want to give it. I don't want to change this. And from which workspace you want to map this, right? We'll say execute this. It goes, it sits on TNA model path. Where's the model path here? Go click here. So if you see here models, we have experiments, pipelines, and all those things, right? You'll find it here. You find very soon you'll find this model here. See this here? Flight delay models. What we are trying to do is we are trying to do it with the Database account or Jupyter notebooks, whatever it is. You can just do the same thing here. And this is automated, right? You don't have to worry about always creating this. And other very important point is, see here the version 1. Again, if I say execute this again, it creates a version 2 inside this. And if I execute it again, it creates version 3. So first of all, registering the model is very important. And we have done it now just now. We are able to see that, right? Everyone is able to see it inside your model section here. Let's go. Now create a scoring web service. So anyone can tell me what is this? Any guesses, anyone?
Yeah, you want to implement the model algorithm on a live data and get the predictions.
Right, exactly right. Kind of what you said is exactly right. So when deploying the models for scoring the machine learning, right? So we have a simple web service that can be exposed in the external world, right? For the simple web service to create it, we have to go with two things. One is the model, other one is a scoring job, right? So this scoring script, there's nothing but a script, a Python script, which will contain two methods inside it. This is a default thing. This should have every scoring file should have these two things. Even if you're creating your own scoring script, nothing but I'll tell you what is scoring script also. Let's assume that it contains two methods: init methods, run methods. So what is the init method? We'll see that. So see here, this is the init method. We have it here, function. So we are importing all the libraries here, right? I'm creating an app called scoring here. I'm getting the model name here. Model path is, this is a model path. Trained model, this one. So basically I'm getting all the handle of initializing parameters. Basically initializing all the parameters, right? And then run script. So is instance trained model? If it is yes, then go ahead, or else return out this exception here. So I'm trying it out here, saying that get a Spark context, get the handle of trained model, prediction model value, cut all those things. So basically, if you observe it, I'm creating a JSON file here again. I'm trying to pass my data, which means that this data here, input underscore df. So what happens with this? Let's say I'll give an example. Let's say every day I created my data factory to have a batch file execution every day, right? Every day I get a new file at around 9 o'clock in the AM, and I pass this into my my scoring script. So that will be an input to this. It goes through this whole system and it transforms this data because it is taking the info schema here from the input file. Okay, it takes the list of this data frame here and transforms and kind of collects all the scored results into prediction column. Now this will be prediction is equal to this one. Confidence is nothing but the interval confidence here. So we have this JSON script output saying that each record, what is the prediction out of it? Let's say if we get a record, is it showing as, if it is 0 actually, what is it showing now? It is showing 1 or 2. Okay, so 0 or 1. We'll define that here. That will be mapped to a JSON response script. That's it. So we're basically creating a new record inside your data frame to have prediction enabled for it. They're saying that for this record, the prediction is, what prediction my model is giving is, it is delayed. It is not delayed. It is delayed. So it gives you the, for each record, it will give you one prediction for it, right? So that is what it is doing out here. And I'll say score Spark ML, execute this model, execute this. Okay, and then once I executed it, I wanted to have this whole script into one variable called, into one file called score underscore spark ml.py. Right. I want to write this whole script into this variable, into this file called score spark ml. This is called nothing but scoring script. As I mentioned you, any web service requires three things. Okay, first one is the model file, right? Second one is a scoring script, and third one is the dependencies. Like let's say if I want to execute the script, right? What are dependencies I wanted? I want to have dependencies libraries as scikit-learn, numpy, and pandas, right? So I will create one more variable here. So let me just go back and confirm it. Everything. It is 4, I guess, not 3. So any model, the sixth point I'm referring to, the 6.1. Okay. Any web service requires below things. First one is the model file, right? Second one is scoring script. Nothing but what you want to execute it. Inside we have what we have inside this. We have our init method. Nothing but initializing all the parameters. And other one is the run method. So what do you want to run? In this we pass the parameter of data, daily data. Okay. And third one, what we want is we want to have dependencies. Like let's say Conda dependencies we call it as. So what does it contain? Like in order to execute the script, right, the run command or init command, we need to have some libraries executed, right? So we can't say that just import. It will not work. We have to first install these libraries, right? So for installing that libraries, we are trying to go with what all dependencies we have it inside it. And the last one would be the configuration files. Are you defined here? Yeah, here. Last one would be container configuration. So what it means is, so we are trying to create a model, right? We want to have a scoring script. Yeah, we want to execute, once your model is generated, we want to pass new data into the scoring script and map it to the model and get the results out of it. And to want to execute this, we need to have counter dependencies. But to want to execute everything, all these things, we need to have an environment, right? We need to have some VM or something. So that's nothing but this one. We create an environment where we can execute all these things. Nothing but Docker containers, kind of container instances. Clear, everyone? This 4 things has to be created. Now we created this one, we created this, now we're creating the third one now. So let me just go up. So we have created this score underscore spark.py py file. Okay. Now I'm creating a test input here. I want to test this output of what are the model we are passing into the system, right? I want to first test it out before creating a web service. I want to test it out. If it's working fine or not. If it's working fine, then I can expose a web service out of it, right? So in order to create a test case, I'm creating two columns here, 2 records. Sorry, one record this one, second record this one. I'm saying init, anybody like execution in init script there, and then I'm passing this into 2 lists here, and this into dumps this list here, and say run. I'm executing init script and run script here. What happens with this? It gives me results. Oh, so I didn't execute this. Okay, I didn't execute this command. So now it will go and execute everything and give you the results out of it. Saying that, see this, the prediction is 1, confidence is this much. For the second one, prediction is this one, confidence is this much. Right? It gives me these results here. Now, yeah, it is giving me right results now, so I can go forward and I can go with the creating dependency files for my Docker container. So I'm just saying that my scoring script requires the scikit-learn, NumPy, and pandas. And I wanted to create a file called YML file. We can't create any other file. It should be YML file only. Okay. So we'll create this, and then go down. Now we have to create. Now we have the score. This also. Now we have to deploy it, right? So which means that we have all these three which are ready for deployment. We can be ready for deployment, but we should have a system or an environment to deploy it, right? So for that, see here I'm creating a configuration of ACI web service instances. We need to have number of CPU cores, size of the memory, kind of what tag you want to give it, and everything here. As of now, it is a very small requirement we are going with. I'm giving you one CPU core, 1 GB RAM for my Docker container, and I'm saying the tag is nothing but, let's say we have hundreds of models. How do you find which model we want to train out with? You can say version 1 here, whatever we want to do it, can do it out. Tags here, and then give some description about it, and say executed. Now this is executed, which means that this is configured. This is not deployed there. This is configured. Just that's it. Okay. So now if I say here service name is equal to, this is the service name I want to give it. Runtime is this one. Driver file is nothing but our scoring file. Conda file is this was a Conda file. So I'll say create an image with this configurations. Clear everyone? I'm creating with the above all configuration. I'm creating an image here, container image, and say execute this, and then now I have the image configuration file here, right? So I can pass this into my web service. I can say I want to create a web service from the model. The workspace, go to workspace. The service name we have it, the deployment configurations, the model we have want to use it, and say execute this. It will take around 5 to 10 minutes because it is creating the image now, and that can be tested out later on.
Can we deploy this in some other container hosting environment, or is it going to be deployed?
No, so it'll by default go to the workspace. Here we define the workspace, right? So there are two ways of deploying it. One is into the Azure Machine Learning workspace, or it can be into IoT edge devices also. So if you go to IoT edge devices, then it's a different case of exposing it. We deploy the model here and then map that model to your container, kind of the IoT edge devices there. It is also possible. Or even you can deploy it into FGPA instances, chip-based systems. You can do all those inside it.
Shashank, I had one question.
Yes.
Shashank, after we have deployed our model and we have created a web service to consume the model, but what kind of architecture design would be there to use this model, like the pipelines that would be created? Will there be real-time data streaming, or will there be a batch service data that would be fed to this model?
Good question. See, that is based upon your requirement. Let's say, it is all a web service, right? This is a web service. So either you can use that as a REST API into your data factory. Let's say, I'll show you that. Anyways, I'm trying to build that data factory now, but we have very less time. But let me to kind of give you a hint of it. How does it work? Okay. So what we do is we run through a batch job daily. Let's say daily morning we get a file. We kind of go through all the transformations in the Databricks or data lake, wherever it is, and then the end result is pushed into your input of this model web service. It goes and executes, and that will be passed into your DB, because it'll have the records as well as the result of it. So I can define my triggers inside my data factory pipeline, saying that whenever you find a record which is less than this kind of timeline, when you get an accuracy less than this record, just push it into my another DB on that table. So this kind of approach we'll do it. If it's real-time streaming, then we don't go with data factory. We go with the event hubs or IoT hubs, or let's say database itself, and then we kind of get the result from here itself and see it off. So we can define the jobs here then, but it's not there.
Okay.
And also we can define which model you want. Let's say we have 3-4 models here. We can define which model to be mapped to which image and deployment version here. That's not possible. You can just see here, we have image, right? Now I can say that I want to use this image or I can use any other image. Okay, got me?
Yes, yes, yes. And can you once again go to that Azure screen?
Okay.
So compute, actually I missed the beginning part. This compute, this is actually our resource group, like AMI whole workspace. It's our
Yes. Resource group, right,
Azure
logical,
model.
yes. Right.
Okay, that is a
It's a
workspace.
machine learning workspace, nothing but highest umbrella, like all the
Okay,
machine learning services. There's a reason for it. Like there's a reason why I mentioned the highest umbrella, because you remember, anyone knows about here? I guess you know about the machine learning studio, Azure notebooks, all those things.
yeah, I know Azure Notebook.
Okay, so this is all you see here: Azure notebooks, visual interface, nothing but your machine learning studio, automated machine learning models. These are all integrated inside one place. You can just go and start creating it here itself. Just go here, start creating your workspace. Go here, start creating your automation learning. So it's all sitting under one umbrella. But what we are leveraging is we are leveraging through command prompt, because we want to automate this process. We don't want to directly come here, do the manual interfacing and do it off and then then kind of expose it. We want to make sure that everything sits in one workspace, one umbrella. Like we can see, even if you create, let's say, even if you create some model inside that automated machine learning or visual interface, nothing but studio, it shows you the experimentations here. Tell you this one experiment here on it. This is the output for it. It'll show you here.
Okay.
Yeah. So that is all defined inside it.
So once we have done creation of the means workspace and creation and deployment of our ML code is done, then we can open up our Azure Data Factory, and we can also link this model with a pipeline.
Exactly.
Okay.
So we have a REST API here, which is generated here. I'll show you here. We'll generate a deployable service here that can be passed into your data factory as a REST API and map it there.
Okay.
Then it'll automatically execute this whole process.
Okay. And we can feed the data through that pipeline to this model.
Yes, that's what we are able to do now. Here we're able to do that same thing now today. So just a higher note, yeah, I guess to answer your question, yes, that is the right answer. And to answer your other question also, so if you see here, right, example is this one, it's not getting created still. So once you get a REST API right here, we go to a data factory. Let's every day morning get a file, right? You get a batch job that will be passed into it. Example here is waiting for this to complete it, so it's still running it. So if you have it handy in with you, you just can see the deploy as a batch scoring. So what I'm going to do is I'll go to my data resource group here. I have created one blob storage, right?
Yes.
I just uploaded few files into it. I'll show you that. In 2017, I have few folders here. Each month, each file we have it, 3 MB of flight data. Okay. So now this data, I'll pass it into through data factory. Like example is like this. So I'll show you that here, the documentation. We have done all these things. Let's move forward. So this is what, okay. So just want to bring up to you, how does it work? So I'll define my data factory here. Okay. And I'll say copy activity. So every day morning I'll start copying the data.
Okay.
On a daily basis, right? So I'll define like this: a daily basis, copy the data from your source location to your blob location.
Okay.
Okay. No indeed. I'm just defining the pipeline here, like this.
Okay.
Okay. And then I'm saying the source is some file system, whatever the location it is. Yeah. And the destination would be my blob storage.
Okay.
Like see here, I just gave this one, and this is the path name, right? Inside this path, take everything, whatever it is there, and then I'm defining. Let me just go down and show you that. Yeah, the destination is blob storage. But again, this is a tedious process, so I didn't do this. The reason is that it will take longer time for me to kind of define my integration runtime, because in this document we are trying to have a mapping between your local system, local file, and your blob storage copying. So I don't want to do that. I just kind of uploaded it directly here.
Okay.
Okay. So once I have the file inside this, I'll just show you that. So this is the folder path I'm giving it here. This is a file path. This is a file path I'm giving it. Just go to this path, like path structures, and make sure that the year is this one. See, this is the variables here. We have it. I'm giving this path here. Merge all the files in a single file. Okay. And then header file is enabled here. And I just want to go forward and show you that. So I copied also to my blob. My next step is to go down 1 second. So now I have a copy activity, right? I'll go and add my Databricks now, notebook.
Okay.
Here. This notebook will contain the batch processing. So example, see here, this is a batch processing, right? If you see down, 1 second, I'll just show you that. Just a moment. This is the fourth one, right? I map this path here, and I say execute it. So every day morning, it'll take the file from the source system, move it to blob, and from blob, it'll move it to your destination location.
Okay.
Yeah. This is what we do it, like this.
Okay.
Maybe you might have to include some data processing here also on the fly, and then do it off if it is a raw file here.
Okay.
Yeah. Got it, everyone?
Yeah.
Yeah, I'll just show you this process also, but it is still running. It will take the 5 to 10 minutes completed.
Okay. Here we are creating the Docker image of the model. I mean, the web service we are trying to
expose now. We're kind of creating the web service now here. It is done.
Okay.
So succeeded service creation operation finished. Let me just go here and see the deployments now. Let's go to this one. Workspace. Deployments. So we see a deployment, you'll find a deployment now here. This is a deployment, right? And we see an image here. This is the image we have it now. Docker is created, Docker image, succeeded.
Okay.
We have a deployment is also done here. To open this up, deployment, see here the scoring URI. This is nothing but your URI, which can be passed, where you can pass the input to this and get the output of it.
Okay.
Right? And this is CPU one we defined, right? The Docker CPU and memory is 1 GB. That's what you're doing a job here. So let's go and execute this. Okay, to confirm what is the output of this. This is nothing but, you remember that we created some test files here above it. Here, JSON, right? You're passing that script into the system and it is giving me the results now. This is a prediction. So your web service is working fine, right?
Okay. Yeah.
You will test that also. Everyone clear till this point? Any questions here? Let me know. Let's go back to my chat window. Sure, Hina. I guess I'll just share that. Okay. So hope everyone is clear till this point. I guess I couldn't see any questions from Swati today. Is it open or fine? Yeah.
Yeah, Shashank, open. Fine.
Okay. Sure. So that is till this point here, and the next step we'll go with the next steps now. We'll go with the batch processing. I guess it is now 12:04. I might take around another 10 minutes to complete this. Is it okay for everyone?
Yes.
Okay, that's fine. Yeah. Then we'll go for it. 1 second, just one moment. Sorry, I'm just waiting for the feedback form to come up. Okay. That's fine. So let's continue. Now, see, we have done a lot of things, right? We have done a lot of changes and processes and everything. So now I want to map with my location where I placed it. That is nothing but my file where is it placed. It is placed inside my blob container, right? I'll go here. I'll go to my location here. Like, sorry. Sorry, what happened to this blob storage here? Spark container, flights data, right? This is the path. So let me just go here and give the storage account name. Account name is Spark container, right? Just copy this, paste it here. This is the account name, sorry. One second. It's a big data blob storage account. Just go and map this big data labs, lab storage ACCND. Big data labs CND. Let's confirm it. BIGDATALABS storage account. Lab storage ACCNT. Right? ACCNT, yes. So the container name is Spark container. That is already there. Okay. Let's execute one by one. This is done. Okay. So I don't want to run this. I just want to kind of run it from my data factory. So I'll just keep it as it is here. And you see here, I'm defining my schema for this input. Okay. So I'm defining the input schema, like the file, what is coming out from my blob or from a source system to blob and from there to your Databricks account is coming in like this. Okay. So we can have all this schema here defined. And then I'm saying that the blob path is, this is the blob path. Container name, account name, blob, flight weather data, percentage, which means that whatever folders we have it inside it, just take it as it is and take the files from that. Schema is equal to data schema, nothing but this schema here. And separator is comma separated, header equal to true. Okay. So then I kind of define the model, getting the model from this here. Pipeline model, nothing but dot load, that is from here. You get the model dot load here. Load this. And then model dot transform, we are trying to apply your new data set. This is the data set we're coming out on a daily basis. We are passing it into the system and they say transform it, get the prediction out of each record, and then write that record's output into my main table called score flights. Clear, everyone? Any questions in this?
Shashank, when we say model.transform, it is actually trying to apply the model into that df delays data frame.
Right. Basically, kind of taking the data from this data set and applying that model on top, kind of applying this data to have that model executed and giving the result output, like whatever predictions it is giving out.
Okay, thanks.
Yeah. So for that, now I don't want to execute this. I can execute it here. But what I want to, as I mentioned to you, I want to do this process through data factory, like a batch process, right? As the first step is copying from your source location to your blob folder, which I've done it manually now because it will take longer time for us. Just kind of just copy activity, right? I hope everyone knows it. So that should not be an issue. What I have done is now I'll take the data factory and I'll add my Databricks notebook into it and execute it. So I'll just go here, go to my data factory, and I'll say new pipeline. I'll just give it as, let's say, ADF batch ML operation, some name, okay, and I'll say take Databricks because the data is already in my blob from my source location. I already uploaded it. So just want to, even if you want to see here, right? Let's say you want to do some copy, you can even do it here. But as of now, I don't want to do it. I can add it like this. But this is already done. I don't want to use it. I want to only use this one now. So for that, I'll say batch scoring. Okay. But for this, there are two things. One is Databricks account should be mapped out. Another one is your settings, the notebook path. So for Databricks account, we have to create the link service. Okay, this is what is required. The reason why I'm telling this point is this is all not required for you to do it because you can directly go here and execute all those things, right? If you, I'm just kind of comparing with community edition. When you have community edition, directly upload all those things and you don't have to worry about. The requirement why we have to go with enterprise scale is because we are trying to integrate with Data Factory. That's the only reason why we are going with enterprise edition of Databricks. So what I would suggest is, let's say if you don't have this instance, maybe tomorrow or after tomorrow, it's okay because you can upload this content into your community edition. You already have a DBC file. Start executing everything. You have documentation with you. Understand it logically that you can do it everything inside it. The only thing is that you may not be able to integrate with this one. That's okay because you will be able to execute the same thing from here, right? So I would say don't worry about the subscription or whatever it is. If you don't have it, it's okay. You can do it from your community edition also. Okay, so I already have a cluster here, right? Let me just click on my cluster, already having it. So database region here is already mapped out. So it's asking me from the access token here. What it means is when you go to your database account here, you're going to generate that. So let me go back, go to my Databricks account here. Okay, see here we have a symbol icon, right? Person icon account, and say user settings. So see here it is generating a new token here. Just copy this new token and say lifetime is for 90 days. This is for ADF integration. Just give some name for batch and say generate. Now it generates this token. You have to copy this, and this is a one-time activity. Again, it will not be shown to you. So then go here and map this out here. When you say access token is this one, which means that I'm trying to access Databricks from my data factory through this token. And I'll just say drop down. It will tell you what all access we have inside it. So I already wanted to leverage this because I'm already using it for all these things, right? So I want to leverage this cluster here. And now I'll say test connection. It's successful, right? Everyone is clear till this point what we have done till now. We went to your Databricks account, access tokens, generate a token. Yeah. Okay. Generate a new token. So we got a new token ID here, and we went back and we pasted it here. That's it, and it basically interacted. This Databricks data factory is able to interact with your Databricks account and found out that this is the lab cluster. We have it, and let's say test connection. It is working fine. Say finish. Okay, so now I'm done with this. Say publish. Oh yeah. So okay, the first thing is done, right? The database is created mapped, but what is that you want to pass it? Say browse. So remember this, right? It has users and my username. This is the path, right? Inside that, the fourth one is what we want to expose it. Click on this, right? And now we're done with this. Say publish. So what we done? We map the notebook path of fourth notebook into the system. It is published now. So you can just say add trigger now. Finish. So what it will do? It will go through all these steps now. Go through all these steps now in parallel internally. Executes all these steps and gets the pipeline, the model name, and then saves that output into my table called scored flights. So I'll just go here and see if it is executed or not. It's still executing it. So if you want to see this, click on this path here. It will go and show you the how is it executing it. This is done. This is done. This is done. Done. See here. Done here. This is all done. This is all done. This is all done. So now I have my data in my scored flights, which means that this processing is done. Confirm it. It is done, right? So I have done my batch processing now, which can be done through your triggers. Let's say every day morning you can execute this, and then come back and say explore data. Now let's go to the fifth one, that is the fifth step. Map your account there and let's see what is output inside this. Clear everyone? Hope everyone understood the concept what we are doing, right? So if you see, this is all the same files, but if you go to last, you find the probability and prediction. The prediction is 1. What is it giving out? Let's go and see this is the 1, see here. This is 1, right? But 2 ones here and another 0. Let me just go here and see this. Same thing is predicting out. That's good. You're able to predict it in a better way, right? And how is it doing out? See here, the prediction value probability is 43%, 56%. So 1 is higher here. But if you see here, 69% is this one and 30% is this one, which means that it is going as 0. Okay? So this way, we are trying to create the whole system. Now, I wanted to kind of define my system in a right way, which means that I want to define my query in a better way. Let me show you that. What happened is, okay, this is underscore. Now I have one more table, right? Underscore CSV. I want to kind of integrate that table in this table and show it off for you. You remember that we have 3 files, right? This is the third file we have it. Kind of having location lookup about information about locations. Okay. The last step is to go and save this into a Power BI report. Okay. So I'm creating. Oh, sorry. Somewhere here we don't have the table. From not this. This one, yeah. Okay. And then I want to say override on this table called flight delay summary. This is the final table. I want to use it for my Power BI reporting. Just say execute and see this. Awesome. We're done with this. So we have done the whole modeling part. And if you observe it, most of the stuff is done by data engineer, right? You're observing it, right? Everything is done by data engineer, not by data scientist. Data scientist part is only for part 2. That is here. Only this part. Remaining all is done by data engineers only. This is only one part, single part. So when someone says that we have a different team on data science, then that's a wrong thing. And wrong thing in the sense we can have different teams, but thing is that it is kind of reducing now. Nowhere we can say that we have a different team for it. It's all unified environment. Okay, that's what the world is going towards. So okay, before going to that, let's take around 2 minutes to complete the feedback. Maybe it takes around 2 minutes for you all. I'm just putting that here in the comments section. In the meantime, any questions you can discuss now.
Shashank, I have one question.
Yeah.
Shashank, in the prediction you had shown us the probability values, but there were 2 values in it. So what was the second value like?
1 second, coming there. Just pasting this and checking it out. Just a moment.
Yeah.
What is this? 1 second, there's something wrong with the feedback form. Oh, it is 9 here, sorry. Just a minute, people. Yes. We can try this once. Let me know if you're able to open that. I'm not able to open it, so sorry. Anyone able to open it? Okay, just I guess I just pinged them. Let me come back to them. Maybe it is some issue. They're still loading. Yes, that's what some issue is there. Okay, that's okay. Let's continue. Maybe they'll respond back in a few minutes, and then we'll give you the instance. So you asked me a question, right? I didn't get you. Sorry. Can you ask me again?
Yeah, Shashank, we had one data frame where we captured the this one, not this one, the prediction values. So the
Yeah.
probability, yeah, the below one, yes. So in the probability we have two values like 43% and 56%.
Yes.
But we should get only one value, right? Like the accuracy
No. So
percentage.
basically, it is saying that I'm confident that I'm confident that this value, this record is giving a 43% probability for 0 and
Okay.
56% probability for 1. So then it will
Okay.
consider and give you the value.
Okay. The overall
That's what it
accuracy of
means.
the model. Okay.
Yeah.
Okay.
Okay.
The overall accuracy of the model was like
Not here.
63%.
Yeah,
Okay.
that is basically saying that how confident your overall model is, kind of an
Okay.
aggregation model. But here it is individual records it is talking about.
Record.
For this record, this is the value I'm giving it out.
Okay. Thank you, sir.
Yeah. So that's fine. Let me just see the. Oh, something is down here. Something is wrong. Maybe I'll just guys for a few minutes we'll kind of see it off. I just share the WebEx link. Sorry, this link. Now see here we have done with this one last step. That is going with okay, just a minute. One second. I'm just trying to. Okay, so now I'll have done this right. Now I'll want to integrate this with my Power BI reporting, right? So we have done all those things. We have done this. We have triggered it, and we got the batch job. Everything is working fine here. Then we saw that output is working fine, and then the last step is to go with integrating with Power BI Desktop. So I'll just go with Power BI. So here there is no direct way of connecting to the Power BI reporting. It is through JDBC connections we have to do it. Just tell you that also. One second. It doesn't work in Mac, so that's the problem. I have to go with Windows again. So it's loading up still. Picking up just a few minutes. So in the meantime, I'll go to my Databricks account and go to clusters and just go to cluster here, and then I'll go down to JDBC connections. Okay, let's do that in the meantime. So I'll go to my Databricks clusters, and then to the select a cluster and down and then go for JDBC connections. So open up this, go to advanced sections here, JDBC connections, right? Just go down. This is the connection path. We have it. Okay. So just go down and you find this one like this and copy this URL here. You have to construct the URL now. So for that you have to copy this and this. Okay. Let's copy this out. I'll take out this. So okay, sorry, I'm just trying to go back and forth. I'm trying to copy this path. So see here, construct the address. Then you will set up for a Spark cluster. So hope then I'm replacing this path here, JDBC Hive 2 was a Spark 2, right? So we're trying to replace that with the HTTPS, right? And then,
Sasank,
yeah.
yeah, this is Kishla. Actually, I have to leave now.
Okay.
Yeah.
So
So
yeah, I guess this is
yeah.
sure. Just a small update. This is my last day. I guess from tomorrow we'll have someone else working on it. So yeah,
Yeah.
because the big data and AI part is done. So I would say you can just kind of connect me on LinkedIn. If everyone, I'll just kind of do it off so that I can share you the kind of the link for machine learning and all those things.
Yes.
Let's just give me a moment. This is my, I guess I've got a few responses. I'll just copy paste this. They can connect me on that. Okay. So send you a link already.
Okay, and I have sent you invitation also.
Oh, thank you. So that's a good thing, and I'm about to share you the link as well. I'll just share you the mail ID as well.
Yeah, definitely. Yeah. Okay. Thanks for your
Yes.
and this training. It's a vast training actually. So
Sure.
I will go through this basically recording and all. If I do have any question, then I will connect you on your email.
Sure. That's fine. And we have a feedback form also. Everyone can open up
Yeah.
and take around 2 minutes and complete it off.
Yeah, definitely. I'm going to do that. Yeah.
Sure.
Okay.
That really helps a lot.
I'm actually leaving for office. Yeah.
Thanks a lot.
Thank you.
Yeah.
Okay.
Okay. So I have shared you the link, and this should be link openable. I hope this should be openable. So yeah, this is openable. You can try it out. Okay. And this is one which we copied it, right? Just now we copied this. Okay. So you can find this URL also here. HTTP. This is a URL also. We have to find it. Example server, like this is what it looks like. SQL from here. SQL. Append up all those things. Okay. So let me just go down, go back to my server and do the same thing now. So I have one more here. HTTP. This one, right? This is a path. Sublime text. So I have here. This is what we have it, right? Let me just confirm it with my documentation. So we have port 3, SQL protocol, all those things till this point or till this lab. Okay. So we have done that, and we go to your Power BI desktop. Okay. And we'll go and get data. Let me just go to my Power BI desktop here. Sorry, I have a lot of things in my plate. So I'll just say here, file get data. Okay. After getting data here, I'll just go with the documentation. So I'll just get data here and go with Spark here. The Spark, mention Spark and give the Spark path, like kind of whatever JDBC connections we have it, and say direct query here, like this, and direct query. Let's see what happens now. I'll just go with the Spark here. Connect. I'll have to go with this copy activity, copy this whole system. Paste it here. HTTP, direct query, say OK. Okay. Now it enter the credentials for the next screen. Username is nothing but a token what we generated now, right? So that is the same thing here. We pass it out. Sorry. Excuse me. Name is token. And this is nothing but our token here. Oops, I lost it. Let me generate one more. I'll go here to my account, just paste it here and say connect. Should be able to connect by this time. I don't know why it's delaying. Yeah, it's done. Oh, how come? Yeah, it's connecting now still. So we got connected just now. So now see here, we have all these tables, right? We're able to, everyone is able to see my screen, right? I'm inside the Power BI. Hello. Hope everyone is able to see my screen. Okay. Yeah. So now I want to get the record that is a kind of already transformed one, that is a flight delay summary, right? I can go there and show you that. Go here directly and say flight delay summary. This is the one I want to get it. And say load. It might take several minutes to load it. That's okay. So you can see all these records here. You just say globe icon. Define all this latitude, longitude, and number of delays. You'll be able to find out like this. Okay. So I guess it is taking very long time, but I hope everyone understood, right? That we'll get like this kind of requirement, and we are able to connect to it. Can try out all these things in your systems. Okay. So any questions till this point? Hope you've enjoyed this, right, everyone? This is a kind of end-to-end workshop, which I would say kind of we can touch base everything in person, kind of in specific. Okay. So, and I have shared you the URL, kind of the URL. Everyone take a few minutes to update this, so that will help me a lot. And thanks, Hina.
Shashank?
Yes.
So now this is like visualization in Power BI, but now
Yeah.
if there are requirements which are like covering visualization as a .NET application, in dashboard application. So how can we expose this in model, whatever we have created,
Right.
then to other team, how can we expose this model data?
So, okay, see, this is a global table, right? This is inside the Databricks. So you can create this, or you can push this data into a SQL DB instead of pushing it into a main table, right? A save as table. You can say we can have a SQL DB connector and load it into the system, load it into the SQL DB table, that they can use it out from there.
Okay.
Generally, this is not a best practice to work with like this because, like, can you tell me why is this not a best practice? Like having the system here. Any guesses why? Because this save as table is having sitting on cluster, right? Okay, yeah.
Okay. So basically, why I'm asking, like, we are working on some common platform, and there are like multiple use cases sitting would be there who will be using this kind of data, like whatever we are fetching through engine
Right.
and all that. So we wanted to make as a common repository for all use cases, and the model also like will get exposed based on their need.
Okay. But one thing I want to know is this common themes, right? Common place, is it Databricks or something else?
And we are still finalizing, like it would be a Cosmos DB only, but like the modeling part and this like all the transformation part we are planning through Databricks. But
Okay.
I like here like how you have embedded your models with the Power BI.
Right.
So we can do it, have it in Cosmos also.
This is
Because
possible, but the only challenge what we find is like kind of I personally felt is this is going to cost you a lot because this should have the cluster always on because this is a reporting layer, right? It should always be on.
okay.
So I would suggest you can create a SQL DB and expose that because it is not going to cost you much. Instead of saving as a table here, yeah, we can have a table here also and DB also because business analysts or data analysts will mostly work on the reporting layer, right? So
Yeah.
that will make their life easier to work there because here it is going to cost you a lot because the cluster should be always on and then it will kind of will continuously charge you.
Mm-hmm.
So instead, you can just create a table here and load it off and leave it off. If it's a machine learning team, that's okay. They can go and on the cluster and do it off. But if not the case, then go for it. Or else, other way is to create a new cluster, which is a low-end cluster, maybe the least one, and map that to this. It will work.
Okay. Yeah, I mean, we had performance related issues also, like I mean, we wanted to expose this data to use case team, and they were facing performance challenge because this API was like first creating or making up the cluster and then dealing with the models and all that.
Right, because
We wanted
the
some
cluster will create
runtime.
the first time the cluster will be created. A kind of a cluster will take a little time to start it,
Yeah,
but once it is created, then it will be faster only. It's not be problem.
yeah, true.
So yeah, that's what the kind of it is not recommended way to do it.
Okay,
But the recommended way is to go with your SQL DB or it can be Cosmos DB also. And you can push it to Cosmos DB and push it from there, read it from
okay,
there. But again, Cosmos DB is costly, right? It is not so easy,
yeah,
so cheaper. So I would say business analysts can directly go with SQL DB. That's a better one to work with.
okay.
Yeah, that's what I would suggest it. Yeah. Any other questions, anyone? Guess we got it. So I'll say I'm just showing you last one and we can leave for the day. We just expose this here. Sorry. This is taking a very long time. Maybe this is take because it's a direct query, it will take a little long time to create it. So
Shashank,
yes,
meanwhile, I had a question, like it's a kind of generic question. For one of the use cases of the client, like, shall I ask you that now?
yeah, sure. Oh, sure. Yeah, it's fine. We can discuss.
Yeah, and like they are having a database which they are currently using for the using the Azure Amazon RDS, which is actually Microsoft Server at the backend,
Right.
and they wanted to migrate to Azure as their target, but they are confused like what to take off because their data size is around 4 terabyte and it is bound to increase and go above 4 terabyte. So their system is also like they have frequent inserts and updates, heavy inserts and updates. So is it feasible for them to use Azure Microsoft Data Warehouse instead of RDS?
Yes,
But
that database is an option. But if you're going more than 4 TB, right, it is always recommended to go with data warehouse.
yeah, but actually, it's actually a costly service also, and it might not function that properly if you are having frequent updates and inserts
Right,
onto that.
right. Yes, that's
So
true.
is it?
Basically, what kind of is it OLTP data or kind of what is it
It's a kind of an
exactly?
it's a kind of an OLTP kind of a system, not exactly OLTP, but a kind of OLTP database. They said that they're having frequent inserts and updates, so they are trying to find an alternative to replace that system with something in cloud. If we go for SQL DB, then SQL DB cannot support more than 4 terabyte.
Yes. So because I mean it's not recommended. It's not about supporting it. Yeah, it may be supporting it, but the kind of the performance will be reduced. Because more than
Okay.
4 TB, it is always recommended that find a better option to go with it. So I would suggest like kind of see it is again yeah there's a kind of they have transactional data, but how about how many reports they are building out of it? It's more about reporting layer, right? They want to have everything in one place. They want to have how do they want to leverage it? They want to read every data and from their reporting layer, or is it only aggregate data they want to have it? So that accordingly they can map it to data lake and do it.
Okay. For
I would
report.
suggest like yeah,
Yeah.
for reporting layer we can have two layers. Like kind of we can have we call it as tappering approach. I'm not sure if you know it. Tappering approach is nothing but like kind of creating the schema and everything in data lake and pushing only what is required to a data warehouse.
Okay.
So this way what happens is you will only run Databricks and data lake one time, maybe daily in the morning, and you push
Okay.
only the data which is required for your end product. That too can be SQL DB. If it is, let's see, if it is more than 4 TB, it is okay to handle in data lake. It's a flat files, right? And you can you can build a schema on top of it. And whenever you get a new file on the clusters, run the data sets, transform it, and do it into your SQL DB layer, which can be a reporting layer for your systems. So where
Okay.
you'll only have aggregate data. Maybe I guess I worked with 1 TB data coming out every day. So we did the same thing. We used the data lake in the medium, and we have only around 2 GB, 3 GB data, kind of optimized two-year data, optimized two-year data logically inside your SQL DB. So it's not
Okay.
going to impact you much. The
Okay.
remaining all will be archived, maybe every monthly once or something. But if you want to have real time, then it is not the case. You have to go with something else.
Okay.
Yeah, that's what. Okay. So anything else anyone wanted to know?
Hi, Shashank.
Yeah.
Actually, I
Hi.
wanted to know how do we implement this data lake on premise data warehouse, like without the cloud?
On-premise data lake, right? You can use Hortonworks something, Hortonworks or IaaS based. See, Azure provides an approach of IaaS based approach where you'll take the control over everything. Like kind of you just have a IaaS instance, map it to your Hortonworks or let's say Cloudera, whatever it is. That should be possible. Where you can have data lake inside the HDFS layer. So from there you can define your process. You can write Hive scripts or Spark scripts writing on top of it. That is again HD, no, not HD inside, but kind of Hadoop based approach. Yeah. I hope I answered your question.
You were not audible actually. I couldn't hear you.
Oh, is it? Hello? Is it? I'm audible now?
Yeah, now you are.
Oh, sorry. So basically, what I'm saying is we can have IaaS-based instances, like kind of Azure mapped with anything like kind of let's say Hortonworks, Cloudera, whatever, MapR. You can have that kind of approach, IaaS-based approach. So that can work. Or else, if you want to have a PaaS-based solution, then you can go with HD Insights. That's the other way of doing it. On-premise, I would say that kind of Hortonworks or Cloudera will help you out. If
Okay.
you have larger
Thank
scope,
you.
maybe you can go with on cloud. Maybe in the future, you can go with IaaS. But again, it is a very tedious and very troublesome process to work with. Very very troublesome. You have to take care of everything there.
Okay.
Okay, sure. Thanks, Akshay. I guess I understand. Thanks for your comments. Thanks, Subramaniam.
Thanks, Shashank.
Thanks a lot. Thanks, Alexander. So, yeah, any questions? I'll wait for a minute, maybe 2 to 3 minutes. All can leave for a. Thanks, Kumar. Thanks, Swati. So you can mail me, Kumar. I guess if you have any questions, you can mail me out, or also I'll be available 90% on the LinkedIn as well. So if it's any detailed one, you can just mail me mail me, or if it is kind of short kind of chat, then you can reach out to me in LinkedIn.
Yeah, Shashank, the mail ID is shashankp@aagasp.com.
Yes, at the rate ASAGS.
Okay.
Yeah, Shashank.
Yes.
Yeah, so regarding my question for the ADLS Gen 2, I'm trying to create the file system using REST API. So how can we use the curl command? I mean, where can we run the curl command to create the file system in Gen 2, ADLS Gen 2?
Curl command, I guess it is mapped up.
Because on the Microsoft documentation, they have only provided the simple put command by which you can create the system. But I don't know how can I utilize it in my current environment.
Okay. Can I have your mail ID, or can you just kind of test mail me once? I'll respond back maybe after the session. Because
yeah, sure. I will.
Yeah, I guess I'm not really sure if I'm missing something in that space, because I guess the REST API is not enabled. I guess still. Not sure. I guess I have to check it. I have to check it once.
Actually, there is only one way by which you can create the file system in ADLS Gen 2, and that is using REST API as of now. But there also, the documentation is not pretty clear. I found a couple of blogs, but still I am not able to proceed ahead for the creation of file system in the ADLS Gen 2. So I will send details to you on LinkedIn.
You can just message me.
With you, so I really need your help to proceed ahead.
Sure, that's fine. I guess once you can mail me or message me or mail me, then I can kind of go back and review it, what exactly you're asking about.
Okay. Thanks a lot, Shashank.
Thanks. Fine. Okay, then anything else, or else you can leave for the day. Thank you all for your time, and I hope you have enjoyed the sessions, and taking the time and spending here is worth it. So I feel that I'm accountable for it, so I have done it a better way. Let me know if you have any questions or anything you wanted to let me know. You can just mail me out, or kind of you can even message me in the LinkedIn. So I'll be responding back immediately, and I'll be sending out the AI URLs whenever I get it out on the way LinkedIn. You can just keep me posted. Just kind of review it. That will help you a lot. Okay. Thank you all. Thanks for your time, and take care. Have a nice day ahead.
Thank you. Thank you.
Thank you. Thanks.
You have a great time.
Yeah. Thanks a lot. Thanks. Yes, Kishore will be taking it up.
I just wanted to let you know. Yeah. So the session will be conducted tomorrow. Many of you have said that it will be difficult to have 4.5 hours on next 2 days, Thursday and Friday.
Yes.
So we'll have it, and whoever is able to attend, you can attend. Otherwise, you can check.
Report. Yeah, that's fine.
Thank you so much, everyone.
Thank you all. Bye.
छह में से 5 लोगों का टाइटल लेवल भी नहीं है और हम इनको